Welcome everybody, Dr. Kutsia here, finally here with my presentation for you. It is a rather extensive presentation, so please take the time to listen to it over time, break it up into little segments. You're going to have availability to it as long as you want to. I'm generally speaking to some of my patients that we had promised that we will provide this presentation to. As well as some of my students and as well as some referrals. So not everybody knows me, so I'm going to go through a little bit of an introduction quickly to give you an idea of who I am and what I do. My background in nutrition is quite extensive. First of all, I hold graduate degrees in psychology, which is really helpful in the clinical application side and the clinical assessment side. But I also have graduate and advanced degrees in holistic nutrition, human nutrition, clinical nutrition, and evidence-based nutrition. So that is pretty much the four major categories that you can specialize in nutrition, and I have degrees and qualifications in each one of those areas. My entire practice is based on a functional model. So what that means is that we aren't the quacks. We're actually science-based, looking at data, analyzing material, going on evidence-based, scientific-based publications. I am personally published in peer-reviewed journals. I have worked in areas of type 2 diabetes and metabolic syndrome with cholesterol-associated issues. And I designed protocols that have reversed, stagnated those conditions, and I have published on that. So the objective of this is to do the same with intestinal permeability. At this particular point, intestinal permeability, I believe, is not attacked the right way. I think intestinal permeability is more a symptom suppressive intervention currently. And as you will see later on when I talk about the different diets that people are on with IBS and IBD and Crohn's disease and diverticulitis, you are going to see that these people are, as a general rule, staying away from huge amounts of foods because those foods cause issues with them digestively. And my point has always been that if a food is grown on this planet, you shouldn't really react to it. And what we've seen is that some people will react to kale and broccoli or asparagus, and theoretically with right stomach acid, with right digestive capacity, with right bacterial balance in your body, you should be able to handle those foods to a certain extent and not have these adverse reactions to them. So I am an associate professor at Maryland University of the Integrative Health. I am an adjunct professor at the University of Bridgeport. I teach various nutrition courses: sports nutrition, advanced lab assessment, pathophysiology, biochemistry, nutritional biochemistry, of course. Let's see, what am I leaving out here? Life cycle nutrition, macronutrients, micronutrients, you name it. Anything to do with nutrition, I basically teach. I am also the Associate Director of the Human Nutrition Tract at the University of Bridgeport for their doctoral program. And I am involved with master's and doctoral level students in the field of functional and clinical nutrition. I have been a clinical practitioner for 20 years, and I am fortunate enough to be in practice with Dr. Prudian at Natural Healthcare Center for the last 12 years. Now, in the process of putting this together, you are going to see that there are basically three categories that we will be talking about in this particular lecture over time. And the three categories are the intervention strategies for intestinal permeability. Now, a lot of people call intestinal permeability leaky gut. I am not a big fan of those terms. In some of the publication, you will still see it mentioned as leaky gut, but I prefer the proper terminology, which is intestinal permeability. And we are going to break that down into three categories of intervention. The first category would be phase 1, which is re-soiling, which is mostly Dr. Bush's work. Phase 2 is reseeding, which is mostly Dr. Christian's work. And then phase 3 is refeeding, which is mostly Dr. Kutsia's work. So it's an overlap of all three. And the lady in front of you right here is really the mother of where it all started, Dr. Stephanie Seneff. I was fortunate enough to speak with her at a conference called the CASI conference, C-A-S-I, which is the Complementary and Alternative Scientific Intervention seminars, in like a TED Talks kind of experience. And I was on stage with Dr. Seneff, Dr. Jeff Bland, Dr. David Brady, and Dr. Deanna Minnick, which are all extreme leaders in their fields, and I was just honored to be on stage with them, speaking at that particular point about some sort of a nutritional associated discussion. Dr. Seneff spoke about glyphosate. Now, Dr. Seneff has a PhD from MIT. Her specializations are twofold. She has a background in computer sciences, so it's very easy for her to collect and analyze data, as well as biology. And she's a brilliant lady, and she has done a tremendous amount of work with glyphosate, the herbicide that's been used in this country very, very aggressively since 1996, as you will see shortly. And she has found biochemical, pathophysiological connections to this particular organophosphate and many, many diseases of our culture. So a lot of the work from Dr. Bush, where he is trying to significantly improve the damage done by glyphosate, is the original work from Dr. Seneff's research on the dangers of glyphosate, and she's been published in many, many articles as it relates to these particular conditions. Now, as the communication will go further tonight, we are going to focus a lot on intestinal permeability. Now, if there's any condition in the world that has the patient at the worst level of digestive issue, it is autism. Autism and people with autism have one of the worst commensal balance of bacteria. They have high levels of ammonia, they have digestive dysfunction, they have constipation, they have diarrhea, they have malabsorptive disease, they have intestinal permeability in the GI tract, they have intestinal permeability in the blood-brain barrier. So the worst form of intestinal permeability's sideline end result is autism. Or one of the major symptoms of autism is intestinal permeability. Intestinal permeability is not the cause of autism. As a matter of fact, I think Dr. Seneff has a good point in thinking that glyphosate has a major role in the development of the autism the way it is as we stand. I could be speaking under correction here, but I believe that in the next 20 years, we will be at a rate of 1 to 3 autism, according to Dr. Seneff. And if that's the case, this country is not able to sustain itself anymore. Because autism is not genetic. With the epidemic proportions of which it's been growing, you cannot write that off as a genetic thing, because genetics is an evolutionary process, right? So you can't just have in one and a half generations going from 1 in 400 children to 1 in 53 to 1 in 3 and tell me it's a genetic issue. It's an environmental issue, and we need to obviously investigate that further. The next player in our discussion is Dr. Zack Bush. He is a triple board certified medical doctor with a background as a professor at the University of Virginia in the medical school, and his specializations as a triple board certified physician, which is very seldomly done, is endocrinology and metabolism, internal medicine, and hospice and palliative care. Dr. Bush also worked on research as it pertained to cancer, He was working in a lab working with various molecules in chemotherapy and certain drugs to obviously attack cancer cells. And somewhere along the line, if you listen to his story, you will discover that he realized that some of these chemicals or molecules that he was researching in a lab, he actually found in soil. And he started to shift his mind to saying, wait a minute, you know, nature has similar molecular structures that fight diseases than what we have in the labs, so maybe I should start investigating that. So he made a very in-depth study on soil and the microbes in the soil, and he soon discovered that there was a couple of molecules that he could find in soil, being involved with humic acid and fulvic acid and other acids, and they modified this a little bit to change the pH of this particular molecular design or structure, and they were able to actually enhance the performance in the human system by utilizing this particular product. And I'm going to do a much better explanation in a couple of minutes when we go deeper into it. But bottom line is that Dr. Bush came from a traditional medical background. He had no interest in intention to investigate nutrition or anything like that in the early part of his career. But he also became frustrated when he saw that some of the medications that he gave his patients made them worse and not better. He eventually opened up a practice where he did focus on nutrition because he studied that to the nth degree. And at some point when he was working with cancer patients and with septic diabetic ulcers, he realized that in his own words, there's really no such thing as disease. It's just a severely confused cell and lack of communication between the cells. So to make a long story short, the soiling or the product that Dr. Bush designed is basically reactivating the communication network in your body. So it's the better ability for the cells to communicate with each other, and it enhances the cellular communication, even almost like a cell phone, where you have a cell tower and the cell phones are, kind of chatting with each other through the people. However, it's not really the cell phones that are communicating, it's signals between obviously the transmitters, that is how the cells are communicating with each other. And this is basically what this product does on a very, very deep scientific level. It actually enhances the ability to communicate cell by cell, and that's how the cells stay healthy, in the communication process. Okay, so phase 3 of the player, or phase 2 in our little discussion, is Dr. Kiran Krishnan. He is a microbiologist and clinical researcher, and his specialty is exclusively the microbiota. So he has done massive amounts of lab studies, publications, teachings in understanding the human gut biome. Many years ago, not many years ago, maybe, I don't know, maybe 10, 12 years ago, or maybe 18 years ago now, the Human Genome project was launched, and we did realize very quickly that we are not as complex as we once thought we were from a genetic or a genome standpoint. We only have between 20 or 25,000 genes. That's not really that different from a bed bug or a fruit fly. It's pretty shocking when you analyze that. But what makes us very complex is the fact that we have these many millions of bacteria in our body, viruses, parasites, and fungi that should, quite frankly, live harmoniously and symbiotically in our system, which, because of our environmental attacks and the way we destroy it with glyphosate, as I will explain from Dr. Senev's work, that we've completely disrupted this gut biome. But Kieran has gone deeper and figured out that there are certain species and spores that do make it to the GI tract or through the GI tract to help repopulate and reactivate that symbiotic balance. He also has done a lot of research that has demystified and clarified some of the myths on taking probiotics, which we will be discussing. He is just a brilliant person. So he has shown with certain probiotics, specifically the bacillus species, that you can heal intestinal permeability and slow it down, which we will discuss in depth, and you will get a very good understanding of why he is the reseeding phase. His work forms part of the reseeding phase. I have used some of Dr. Krishnan's material, which I obviously give him full credit for. I've used some of his slides because I can't explain it better than he has. All the credit to Dr. Krishnan for the work that he's done, and the fact that we're able to collaborate with him and use the product that he is behind in our intervention. Now, I can't go any further without thanking a couple of people at my clinical office. Dr. James Prudian, who is the owner of Prudian Healthcare, a natural healthcare center, who I have been in business with for 12 years in our clinical nutrition department. He is the sole owner of the entire practice, but we have a business a partnership in the clinical nutrition side. This is also the office where I've done most of my clinical research out of for my case series trials and my case publications. Dr. Prudian has given me 100% free reign to run that clinical department the way I want to run it, because he always says that the baker should bake, and some people are bakers and some people are winemakers, and we at that office we try and keep in our own lanes. The office is packed with physical therapists, chiropractors, massage therapists, and acupuncturists. So we are a very integrative practice, and nutritionists. And then I really have to also give a shout out to Angela, my clinical nutrition assistant, who is also one of my graduate students. And Dr. Prudian and I are always worried about losing her, so hopefully she'll stay with us through her graduate work. She's totally my right hand, and she will be the gateway of communication to me at all times, as she has done for the last 6 months or so that she's been with me. She is a brilliant clinician in her own way. She's very creative. She has actually designed 1 or 2 protocols of her own, which I compliment her on, which we will integrate here and there. So she is definitely the person that would be answering emails and getting back to me and communicating with me in reference to your experience of this presentation and the continuation of the utilization of the protocols that we've put together here for the intervention. So there are a couple of women in my life that are very important to me, and Angela is certainly one of the top 4. So I just wanted to give a shout out to her and thank her for everything that she does for me. All right, so let's get to the nitty-gritty of everything. As I said, what we are working with in here, and everybody that is listening to this lecture has some sort of a tie-in to intestinal permeability somewhere, somehow. So what you will find with intestinal permeability, or for the final time leaky gut, is that there are associations between this condition and the brain, the skin, the endocrine system, the colon, the joints, the muscles, and the nasal cavities. So the conditions that are directly associated with intestinal permeability will be ADD, ADHD, and autism, Alzheimer's disease and depression, acne, rosacea, Hashimoto's thyroiditis, Graves' disease, inflammatory bowel diseases, irritable bowel syndrome, colitis, diverticulitis, adrenals with chronic fatigue syndrome, fibromyalgia, arthritis, and rheumatoid pain, because of the fact that there are certain toxins, chemicals, undigested proteins, and food particles that get through the digestive system into the bloodstream, which activates the immune system and causes an autoimmune-like attack on tissues. So what I want to say is that if you really analyze this stuff, you always have an outside agent that's attaching to the human tissue, and then the immune system is attacking that outside agent, but unfortunately it is attached to human tissue, and that is now perceived as an autoimmune condition. So what we need to do is we need to start not just doing food elimination diets and taking painkillers for intestinal permeability. We have to start investigating how we can physically reverse this condition in the same way that we've done nutritionally with type 2 diabetes and cholesterol in some of my protocols. So for the last 2.5 to 3 years, I've been working on understanding scientifically, biochemically, how I can put something together to reverse intestinal permeability. And I think that we have found that potential intervention right at our doorstep at the current time, and that's obviously what this is all about. As I've said earlier, there are 3 phases to it. There is the reseeding stage, there is the resoiling stage, and then the refeeding stage, not in that particular order. We start reseeding and resoiling at the same time and refeeding at the same time, so it's pretty much an interrelated thing. But as you see at the end of my presentation, when we get to the refeeding discussion, you will see that I have divided intestinal permeability into 3 levels. There is a level 1, which is a, let's say, a moderately chronic condition. There is level 2, which is severely chronic, and then we have level 3, which is very severe form of intestinal permeability that maybe hits about 7% of the population. I have not seen that a tremendous amount in practice, but I am seeing more and more of that. So level 3 for me would be autism. Autism would be a level 3 intestinal permeable condition. These people at level 3 are also the people that basically can't eat any food. They're down to 1 or 2 foods. Even water affects them negatively. They feel the best when they don't eat. And that's interesting because we will be talking about intermittent fasting and how intermittent fasting actually helps to repopulate some of the species in the gut biome, and that might be the reason that we are feeling better. They are actually called the Akkermansia species, which makes up about 10% of the GI tract. And also when you intermittently fast, your body is actually producing these beta-hydroxybutyrate ketone bodies, which are healing in nature. So you don't need to remember all those fancy names. Just remember that if you actually fast, you can actually improve your gut health. Now that doesn't mean that we're just going to have everybody fasting, because a lot of people are so compromised metabolically and blood sugar wise that they'll have hypoglycemic crashes, they'll get hangry, and we obviously don't want that. That's where the individualization of this particular program is going to come in very importantly. So let me explain to you now what tight junctions are, what zonulin is, what intestinal permeability really means, what an epithelial cell is, what a villi is, because if you understand all that, then you'll understand the rest of the presentation in this lecture. So basically, if we're looking at a healthy gut versus a leaky gut, and there's my favorite word again, leaky gut, we will see that in the left side here that a healthy gut is a normal intestinal permeability, intact intestinal barrier. So yes, we need to have normal intestinal permeability. We are not going to permanently seal these tight junctions. They are there for a reason. They are supposed to open and close like your mouth. And then leaky gut is the increased intestinal permeability and the damaged intestinal barrier. So if you look at this picture, I think it's a fantastic demonstration of what we're talking about. In the left side, you will see that on the top there we have the intestinal content, which if you look at the bottom, it's some gut microorganisms, including bacteria that are beneficial and pathogenic. We have food particles like gluten, lectin, and sugar. We have some stress hormones. We have some toxic chemicals and pesticides that are floating around there. And then you see the second layer of that is called the mucus layer. And the mucus layer is actually broken down into two categories. We have a really thick mucus layer right at the bottom, and a kind of more fluid mucus layer as the intermediate. And then we also have these biofilms that are formed by these different bacteria to protect themselves, that actually also form some form of a protective barrier against you. Then these little finger-like tentacles at the top there, if I can show you on those little babies right there, and the top, those are called your villi, and at the tip of them you have a microvilli, and their job is to kind of pull some of these nutrients in and then take it through these little tight junctions. It's a very complicated thing. We also have the epithelial intestinal cells. So just to give you an idea of how microscopic this is, these cells are almost half the thickness of a human hair, and you only have one cell layer that is keeping you away in your lamina propria, or the inside of your lumen in your bloodstream, from toxins and invading agents. So the communication of the bacteria, the mucus layer, the villi, and these little gates that we have here are all there to protect and take the nutrients in. So basically we have the villi. The villi is out there. The nutrients are coming in, and look at the villi as a coral reef. So these nutrients are coming in, these different forms of fatty acids, amino acids, and all the things that are correct for us, and sometimes a protein structure that the immune system needs to destroy. And that's why there is a communication between these bacteria over here and the GALT, which is on the other side of this epithelial layer, which is gastric associated lymphoid tissue, which is how we communicate with the immune system. So pretend my thumbs is the GALT, in a very general explanation. We have the villi, and then we have this little gate that opens. It gets the nutrient in, and it closes up. So when this gate is opening, there's something called zonulin, which is a protein structure that's communicating to open and close the gate. And if these gates stay open too long, some of these things will obviously escape and then overactivate the GALT where my thumbs are. So if you look at the picture on the right side, you will see that it becomes compromised. That little connection between the tight junctions starts splitting apart. There's a lot of things that are now escaping through, and this is the inflammation state, and this is called translocation of intestinal contents, food sensitivities, and then the autoimmunity. Now, just to summarize what I've just read, we can now see that the intestinal barrier permeability refers to a dysfunction in tight junctions whereby foreign substances like antigens, inorganic compounds, pathogenic organisms are allowed unregulated passage from the one side to the other side, in layman's terms. Tight junctions are found on all epithelial and endothelial systems, such as the nasosinuses, digestive tracts, renal tubules, blood-brain barrier. So am I saying that you can be intestinally permeable in each one of those categories? Yes. Just remember that your digestive tract starts from the nasal cavities, into your mouth, down into your esophagus, into the stomach, into the small intestines, the duodenum, the jejunum, all the way through the distal ileum, into the large colon, to the rectum, to the anus. The entire thing is layered with these little tight junctions all the way down. Tight junctions are comprised of dozens of proteins that aid in this function, including the occludin proteins, the junctional adhesion molecules that we will discuss later on in Dr. Christian's work, and the claudin families of proteins which span the paracellular space. Occludin proteins are responsible for intracellular signaling within the tight junctions, while the JAM proteins aid in trafficking the immune cells and the injured inflamed tissues. So I know this sounds very complicated, but let's look at the next picture and I will be able to explain all of that for you. So in this picture you can see what we are talking about. So once again, at the top here with these little finger-like things, these are your villi, correct? These little areas that are sewn together almost is your tight junctions. Now you can see that there is something called the paracellular penetration of antigens when these tight junctions are dysregulated. Then you can have these problematic things escaping into the bloodstream. We also have transcellular penetration of antigens, which means that it can kind of split down the middle here and also go in through the cell. So paracellular is between the cells and transcellular is through the actual cell, and we have all these things playing a role, of which occludin is basically the closing and the zonulin is sending the signal to open. And then we will talk very, very much about lipopolysaccharides later on, as we get further down the road. So you can basically see that this is your digestive tract. This is where all your commensal bacteria are lying at the top. And then obviously they can escape through all these areas and get into the bloodstream where the immune system is now going to get activated. And that's really all you need to understand about this. Now, if we look carefully at the next slide, you will see the progression of how these villi atrophy and how this whole tight junction dysregulation thing starts happening. You can see on the left side we have the pre-infiltrative state with normal epithelial cells, healthy villi, no real invasion on the transcellular or the paracellular level. Then we have a phase 1 infiltrative state where you can see that there is some damage and some of these toxins are starting to, and undigested proteins are starting to get through the system. Then we get into a infiltrative hyperplastic state where it gets more progressive. We get into a flat destructive state where there is a lot more autoimmune and immune cells involved. And then we get into an atropic hypoplastic state where we basically have total atrophy and completely disrupted villi and tight junction function. So basically it's the progression of a disease here over time, as you can see, and the unfortunate thing is this can happen at many, many levels in our body. So this is a slide that I that I show pretty much to all my students in all my classes. And this is your entire GI tract in one drawing. Now I know it's discussing gastric bypass surgery, which is another insane surgery that we give people for weight loss. But if you look at the esophagus at the top, the stomach, the duodenum, which is 30 centimeters long, the jejunum, the ileum, and the large intestines, this shows you all the nutrients that are absorbed in all these little areas. And what we've just looked at are all the villi, so they're on the inside here, and the tight junctions, they're going all the way down from the esophagus, all the way down into the large intestines. And these are the things that are getting compromised. Now, if you see all the vitamins and minerals that they're supposed to be absorbing and you have villi atrophy and compromisation, then none of these nutrients can really be absorbed. And if we look at vitamin A, D, E, and K, we look at thiamine, riboflavin, niacin, magnesium, iron, calcium, phosphorus. There's a million conditions that I can associate with a malabsorption of these nutrients. Calcium would be osteoporosis. Magnesium, you might have sleep issues and migraines. Iron, you can have iron deficiency anemia. Copper can be involved with the iron uptake in the body. Selenium is involved with the thyroid. All the B vitamins are involved with the energy pathways. Vitamin B6 is involved with how your liver is detoxifying certain protein structures to ammonia, to the urea cycle. Zinc is involved with your immune system. Chromium is involved with blood sugar regulation. All the lipids, the fatty acids, are involved with cell membrane functioning. So if we have a compromised GI tract, we cannot absorb any of these nutrients properly and we cannot build structure. So once again, if we get back to autism, which is the most compromised intestinal permeability state of any condition in the world, you will see that all these kids are deficient in most fatty acids, amino acids, minerals, and vitamins because of the complete villi atrophy that is happening and the tight junction dysregulation. So that is the entry, and now we're going to go into phase 1 of our discussion, which is Dr. Bush's work, followed up by phase 2, Dr. Krishan's work, followed up by phase 3, which is Dr. Kutsia's work, me, and then the overlap of all of them together. So yeah, let's get busy. Okay folks, so The intestinal permeability restoration protocol is broken down into 3 phases. And the first phase is resoil. The second phase is reseed. And the third phase is refeed. Now, the reason that I'm giving you this total explanation is because I want you to understand why we are all without soil currently in our GI tract, or what is the major culprit in affecting our soil quality that is the baseline for our healthy communication between the bacteria in our system. Just the way that soil and nature will have fungi communicating with bacteria, communicating with certain viruses, to enhance the plant's life, because the plant uses some of the fungi and the bacteria and the viruses and the parasites to kind of make itself grow into a healthy specimen or a healthy plant source. So because of our modern diet, we have lost some of our soil quality, and this is why we always say get back into the dirt, touch the dirt and play with the dirt. But it's almost dangerous to say that nowadays because of this chemical that we're going to be discussing, so in-depthly, glyphosate. And this is the thing that is really actually depleting the soil of all its minerals that is so vital, to our health. But with the work of Dr. Bush, we are able to actually modulate and resoil, our gut biome so that we can reseed it and then refeed it, so we can get those species to grow back to the level that they're supposed to be at. So once again, I know it's a very in-depth lecture, but at the end of the day, what you're going to walk away with here is resoil, reseed, refeed. Everybody is going to have a different refeeding stage initially, depending on the severity of your intestinal permeability, but everybody should be doing the resoiling and the reseeding initially. And the reason I'm going so deep into this right now, and why I won't go super deep into the refeeding, is because the refeeding is where you see me individually or work with me and Angela to get to the bottom of exactly what stage you're in. But the resoiling and the reseeding needs to happen before the refeeding can happen. So most of you that are working with me currently are already on some sort of a refeeding phase, because of elimination diet, because of inflammatory reduction protocols, or whatever we've put you on, is already a step in the right direction. So if you have worked with me in the past, you're already out of that phase of the initial steps to improve it. But resoiling and reseeding is absolutely essential baseline for everybody. The only difference would be the dosing. What level of dosing are we going to give you in these 2 phases is what basically going to be the cardinal difference. Okay, so now let's discuss this thing that is absolutely destroying us currently in this world. What is it? What is exactly the cause of this? It's this fantastic little product called Roundup or glyphosate. So glyphosate, from a biochemical standpoint, is a organophosphate, which means that it has a glycine in the middle, and then it has an amine group and a phosphate group on each end to make it an organophosphate. Now that might mean nothing to you, but understand the following, that glyphosate is a water-soluble molecule, which means that it can go anywhere quickly. It's also not a very big molecule, therefore it can get in everywhere, okay, which makes it such an effective herbicide. It is the most successful herbicide in the history of science, okay, so it certainly does what it's supposed to do, but unfortunately there was a big mistake made in what they missed and what it also destroys in our system, which is what you will be learning very shortly. Just to give you an idea of what organophosphates do, in the same family is something called Agent Orange. Now I'm sure that if you've watched old Vietnam footage from a war channel or a history channel, you will see these planes fly over and throwing out this disgusting vapor of orange fumes and spray. And this was sprayed on the jungle in Vietnam to destroy the plants, to defoliate, to destroy the foliage by virtue of the systems of what organophosphates do. And in the same place, once they defoliate, now they can actually see where the enemy is, because that was the big thing with the Vietnamese, is that they were able to hide, obviously, in the forest, and you couldn't find them because they were native to the area. And unfortunately, we destroyed unbelievable amounts of beautiful world there, and people today still have issues with birth defects, autistic behaviors, neurological disorders, and soldiers that have come back from the Vietnam War, unfortunately being treated like total garbage by virtue of when they came back with the anti-war approach, as well as you know, the diseases that they are developing or were developing from being exposed to Agent Orange were just astronomical, and none of that was ever acknowledged as being you know, being a problem. So that's kind of a sad affair. But just to give you the idea of the family that this product falls into, is the same family of chemicals that destroyed nature and forests in Vietnam. Okay, so now we're going to look at the growth of the use of glyphosate in the United States of America. So the use of the wheat killer glyphosate has rapidly increased in the recent decades. Despite the rise of this use, there's very little published on how dangerous that could be for us. But I'm going to tell you how dangerous it is going to be for us, or already is, because it's already created one of the largest epidemics of chronic disease in the United States of America, and malabsorption, and gastrointestinal, and neurological, and autism. I can go on and on and on. But just let's look at the facts and figures. So between 1975 to 1984, there were 26 million kilograms used of this stuff in this country. Between 1985 to 1994, it was 77 million kilograms. Do you understand that from 1994 or 1996, kind of when the genetically modified foods were kind of coming into the equation, that we went from 77 million kilograms to 1,070 million kilograms. I mean, that is an astronomical increase. It's like a 100-time increase, or a 10-time, 20-time increase from where it was less than 20 years ago. And you can see the massive increase between 1995 and 2004, and that actually is completely correlated to the intake of genetically modified foods, or the production of genetically modified foods that were originated in 1996. Now, I don't know if anybody ever sent you a memo, but nobody sent me a memo to ask me if it's okay to use genetically modified foods in our food supply. I certainly didn't get the memo, and I'm sure that you didn't. And look at the shocking amount that we have currently. Now, why I have this slide up here is because I just wanted you to show you that not just genetically modified foods contain glyphosate. So I'm going to go through them with you. Corn is genetically modified, about 96% in this country. Soybeans, approximately 94%. Wheat, none. There's no genetically modified wheat in this country. They are available, but they haven't been put in the food supply yet. Cotton is genetically modified. Vegetables and fruits certainly aren't genetically modified. And I'm not talking about hybridization. I'm talking about genetically modified. Rice is not genetically modified. Orchards and grapes are not genetically modified. Alfalfa is genetically modified. And hay and other pastures and other crops are genetically modified. So these things are still sprayed by glyphosate. Like I explained the history of glyphosate and how it works. These things are still sprayed by this disgusting chemical, so we can harvest it earlier. So we are all exposed to this. Even if you're buying organic vegetables and fruits, you are getting glyphosate on your food supply, as explained in the urine content of everybody in this country that have derivatives of glyphosate in the system. It's a water-soluble molecule. It gets into the water table. The farmers take the water from their farms, on organic farms, and they spray it on their food. There is residues of glyphosate on organic. Now you're going to say to me, man, you're giving me the doom here and the gloom. Yes, I am. But the wonderful work of Dr. Bush and Dr. Krishnan and Dr. Seneff have been able to give us something that we can start protecting the body a little bit from this chemical until we get it out of the food supply. We certainly can't go any higher in the food supply, because we will not get to a point where we can reverse it. Right? At this particular point, we are starting to see a reversal. There is more of a stagnation now in the use of the herbicide. That's why the company is starting to try and make it a antibiotic. You know, they want to use it for a bazillion other things. But the bottom line is that you can see here the increase of the use of this herbicide all around, whether it is genetically modified, whether it is standard, or whether it is organic. You are going to get glyphosate on there indirectly. Now, they're not directly spraying glyphosate on organic vegetables and fruits, but they are indirectly getting it because we even have it in our rainwater. As I mentioned in the previous slide, that here are some of the documented data on testing done in glyphosate in urine results. And you can see that Canada's average is 3.9 parts per billion, and the Canadian average is higher than the US average, except for North Carolina. North Carolina has a parts of 7.9. So you can see every one of these areas in the United States of America. We are the biggest user of glyphosate and Canada in the world. Which explains, you know, a lot that's going on currently with our health. So if you were to run out, and I have that ability if you wanted to, I have the ability at my office to provide you with a glyphosate test. It's an inexpensive test. I think it's about $100, where you can test yourself for the level of exposure of glyphosate that you have in your body. And it might be an interesting thing to look at, because once we do these protocols, we can see the reduction in the urine. So you can actually look at the progress of the reduction of what you have in your system. You can certainly email my assistant Angela, and she'll be able to provide you with the information on the test that we can use to test for glyphosate. Okay, so let's look at the history of glyphosate, because it's such an interesting little molecule, as we've discussed a little bit earlier. Extremely dangerous, but let's look at the history of it. So in 1964, glyphosate was used as a descaling agent, and the US patent is given to you there, 3160632. And basically a descaling agent in the old commercial boilers and old industrial pipes. You know, a lot of the water flowing through there causes this buildup of metals and sediments, and what glyphosate was originally used for was to descale these heavy metals. So they kind of a chelator, so they pull the metals out, and then what happened is they took this this water or byproduct that they did when they flushed out these boilers and industrial pipes, and they just chucked it next to the building in nature, and very shortly they started realizing that it kills all plants. So clearly in 1969, Monsanto, or the J.D. Searle Company, I think is what they were called in those days, they quickly patented it as an herbicide because they knew that it could kill any kind of plant and plant life. So it's a great herbicide. So in 1996, they went further and they started inserting this GMO crop, where they started doing genetic modification to these particular crops like corn, soy, alfalfa sprouts, where they could actually spray the plant with glyphosate at the same time as spraying the weeds, and then because they were Roundup ready, the plant wouldn't die. But you have to understand that the plant still has the glyphosate on them, and to make it Roundup ready, they have to insert it with all sorts of bacteria and toxins to be able to withstand this, which makes it even a more toxic food to eat. Then in 2005, they started using glyphosate as a desiccant. And a desiccant basically means that if you want to harvest crops, you want to get them reasonably dry, because if they're wet and full of moisture, you can't cut them as easily with the equipment, that cuts the or harvests these grains and paddies. So they dry them out by giving them glyphosate. Now, I don't know if you've ever done Roundup Ready in your yard. I hope you're going to stop after this video and tell all your neighbors to stop, because it gets into the water supply and in our rainwater because of that, and the water table. But if you ever sprayed a dandelion with Roundup Ready, within an hour that thing is dead, right? It's completely destroyed, and because it dries it out. It's a great desiccant. And in 2001, Monsanto applied to use Roundup or glyphosate more specifically, and they patented it as an antibiotic. So we all know that, even medical doctors know, and all the people in the medical profession know, that if you give a person an antibiotic, you destroy their gut bacteria, especially the commensal species or the good bacteria. And that's what this stuff does 24/7. So without you being on an antibiotic, you are on an antibiotic 24/7, just by virtue of the slides that I've shown you previously. The fact that you have that in your food supply and in your urine at the current time is clear evidence that you are permanently on an antibiotic. So there's the history of glyphosate, from a descaling agent to an herbicide to a Roundup genetically modified organism to a desiccant to an antibiotic. Pretty phenomenal, dangerous little chemical, right? Now, this is something quite interesting that we could probably look at, and that's the fact that Monsanto is now encouraging farmers to apply Roundup Ready to many of its crops, including the wheat, the barley, the oats, the canola, the flax, the peas, the lentils, the beans, just so that they are harvested for you to eat them earlier, as I just explained to you a couple of minutes ago. And the reason for that is because of the drying out process, right? So if we look at that little slide there, we can see that canola, corn are the only two ones that are genetically modified there. Lentils aren't, beans aren't, flax isn't, wheat isn't, barley isn't, and oats isn't. So we are starting to hear that a lot of people are saying the lentils and the beans produce these lectins, and that lectins are extremely dangerous to the GI tract. I do know that lectins are reasonably aggravating to some people, but are they really the aggravator, or is it maybe the glyphosate? Or alternatively, is it really gluten that is the major culprit, or is it potentially the glyphosate on the gluten that is doing more damage? Now, scientifically, the work from Dr. Alessandro Fasano has proven that alpha-gliadin, or gluten, in wheat, but there's other glutenins also in the form of corn and oats and barley. They all contain these little protein structures that could actually negatively affect the tight junctions. But they are much bigger protein structures or designs than glyphosate is. So we do know that they aggravate. We do know that they could be problematic to villi, but I'm not so sure anymore that they may be not less aggravating, quite frankly, to the villi than glyphosate is. And this whole theory on lectins, lectins are bad for you. Populations like Mexico and other countries have been eating beans for thousands and thousands of years. So I find it very hard to believe that we can't somehow break it down. Some of us don't have the enzyme or enough of the enzyme, or might have a genetic predisposition. But once again, that's a food that's grown on Earth. From an evolutionary standpoint, you should be able to handle it, to break it down, to utilize those nutrients, in your system. That's just food for thought. All right, folks. So now we're going to get a little bit more biochemical and technical here for a couple of seconds, but I do think that it'll be really helpful for you to kind of understand this. So once again, I'm going to read this, and then I'm going to give you the layman's explanation so that you can kind of understand what I'm talking about. So glyphosate is the active ingredient in the herbicide Roundup. It is a broad-spectrum herbicide considered to be nearly non-toxic to humans. Wait a minute. So if I'm saying that, what's the point of this whole discussion? Hear me out. Glyphosate suppresses the 5-enol pyruvyl shikimic acid 3-phosphate synthase, which is an enzyme. We're just going to call it the EPSP synthase, which is a rate-limiting step in the synthesis of the aromatic amino acids, tryptophan, tyrosine, phenylalanine, in the shikimate pathway of bacteria and plants. In plants, the aromatic amino acids collectively represent up to 35% of the plant's dry mass. Now, what the heck does that mean to the average person? Well, very simply put, Monsanto has hung their hat for the last 30 years or whatever on the fact that humans do not have something called the shikimate pathway, which is this puppy right here. But all plants and bacteria have the shikimate pathway. Now, if you guys can remember, a couple of years ago, they did something called the Human Genome Project, where they discovered that we have between 20,000 and 25,000 genes. We are less complicated than a fruit fly and a banana, or a chimpanzee. So the bottom line is clearly something else is helping us express our genes. And here's what it is. We have more bacteria in our body than cells. So bacteria outclass us 90 to 10. So for every 10 you have, 10 cells, you have 90 bacteria. Does it make sense? So they have over 100 trillion exposures in our body. If I destroy all the bacteria's shikimate pathway that helps you stay healthy, then you are effectively destroying the human, correct? So it is correct, humans don't have a shikimate pathway. But that's almost like saying, well, bacteria doesn't have any benefit in our body. It has all the benefit in our body, because that's 100% what our digestive tract is surviving on, is the symbiotic relationship of the bacteria. So I hope that is very clear to you, that you are effectively destroying or inhibiting or declassifying your bacteria in your gut by destroying them. Now, if you know that tryptophan is the precursor to serotonin, which is a neurotransmitter in your brain that's a happy chemical, okay, and that then converts to melatonin that helps you sleep. If we look at tyrosine, tyrosine is the precursor to dopamine, and dopamine is your overall feel-good chemical. So the happy and craving chemical and the feel-good chemical is pretty much inhibited by the use of glyphosate. Could that not potentially explain the amount of depression, anxiety, and sleep disorders that we have currently in this country? So once again, this little insidious structure of glycine and an amine group and a phosphate group called an organophosphate in the term of glyphosate is a major disruptor of our gut biome. It destroys it. So you basically take Roundup and spray it inside your gut the same way that you're doing it outside in your driveway to get rid of that dandelion. The problem is that the dandelion that you're killing is actually one of the most potent anti-cancer foods known to humans on this planet. So think of it that way. Every time that you spray a dandelion and every time that you eat glyphosate in your body, you're killing those natural dandelions inside of your gut that actually prevent you from getting certain terrible diseases. Okay, folks, so here is a summary of the shikimate pathway. So once again, we said that glyphosate inhibits the EPSP synthase enzyme, right? This means that everything beyond this point is not happening. This is not happening. So the phenylalanine, the tyrosine, the tryptophan, and what I didn't mention in the previous slide is that tyrosine is actually the T in T4 and T3 of your thyroid. So there's another connection to the potential thyroid. So what is the big deal? Remember we said earlier that glyphosate is a chelator of minerals. So in the middle of all metalloproteins or protein structures or enzymes, like this particular one here, there is a metal in the middle. That's why they call them metalloproteins. And what glyphosate does, it actually pulls out that mineral, and then that mineral is obviously no longer available for that plant that is very, very much involved with the process of how that plant is producing these amino acids. So if you pull out the mineral, it's like taking off the tires of the car and now you're going to go for a drive. Might be a $200,000 car. If it doesn't have tires on it, can't go anywhere. So the manganese in this particular one is pulled off and now you can't drive the car. Okay, and it's a completely useless $200,000 piece of equipment that can't go anywhere. You can only look at it. So at the end of the day, when we take all this into consideration with the chelating aspect of it, you can understand that the job of glyphosate is to pull minerals out of the plant, and that's what really kills it. And if I pull minerals out of your body, you're going to die or you're going to get sick, because minerals is part of everything. Manganese, boron, copper, magnesium, iron. All these minerals are on your body. Selenium is involved with the thyroid. Manganese is involved with tons of functions. Copper, you name it. I mean, there isn't a human function in the body or an enzyme in the body that doesn't use these metals. And this is what it does. I mean, glyphosate physically pulls out the metals. Now, as I mentioned in the previous slide, glyphosate is a chelator of minerals. It's a descaling agent, and a descaling agent means that I am pulling the minerals out, as I've explained to you, with the whole metalloprotein thing and the shikimate pathway, and especially the manganese as it relates to the shikimate pathway. But because it chelates all minerals, we have to remember that these cytochrome minerals or these cytochrome enzymes that we are talking about here that contain all those little metalloproteins are liver detoxifying enzymes, and that's why we find so much association with liver issues and kidney issues when we are working with people that have excessive exposure in glyphosate in certain chronic conditions. So the chelation of this mineral is not exclusive to the shikimate pathway, clearly, but it is obviously very associated to the minerals that we are depleting out of our systems, and the cytochrome P450 enzyme, once again, is an enzyme group that are very, very correlated to some of the detoxification ability of the human body. So here we go, folks. Here we have a metalloprotein, and you can see that these metal ions are cofactors in this whole process. And these are the things that are being chelated or pulled out of these enzymes or these pathways, because these enzymes form part of the pathways, do you understand? So they like the intermediates between the different steps. And if you pull the metals out of these enzymes, then these enzymes can't function, and then this whole structure collapses. And you can see here that we have beta-pleated sheets, and we have these alpha helixes, and this is how we design these quaternary protein structures, these very, very complex enzymes that help us not only digest foods but build structures. It helps us to fold things and proteins to build certain tissues in the body. So these things are involved with just about every step. Like you could see with the shikimate pathway, it's involved with how that plant is producing some of those amino acids for its own survival, and then we destroy that by basically pulling these metal out, and specifically the manganese. I do want you to understand that we have so many metals in our body, and these enzymes are so important, and we can't really afford to pull these metals out to the level that glyphosate is doing at this current point. Now here's something pretty shocking and interesting for you to know, is that many years ago it was very, very standard knowledge that the weight of a bushel of corn was 56 pounds. And that was just a measurement structure that was used by farmers and people in the agriculture industry, is that if you buy a bushel of corn, it's at 56 pounds. What they have found in Canada and America with genetically modified crops is that a bushel of corn now weighs 54 pounds. And the only thing that the scientists can determine where these 2 pounds went is by the loss of minerals. And that would make all the sense in the world of what I've just explained to you. So just understand this, that food might look the same. Some people even claim it tastes the same. I don't think that's true, but let's say they do taste the same. What you are missing are the vitamins and minerals. I mean, specifically the minerals. And without the minerals, it's like the foundation of a house. You know, you cannot function without proper minerals. So a lot of the problems that we're seeing today in different conditions, like for instance thyroid disease, where people have low thyroid hormone and low conversion of thyroid hormone, that's generally a selenium deficiency. And a lot of these deficiencies that we're getting is coming from the depletion of these minerals out of our food supply by virtue of glyphosate. So here's just an interesting fact that we know about, but people seem to just ignore it. You know, 56 to 54, that's 2 pounds per bushel of mineral loss. That is a shocking amount of nutrients that we're no longer getting into our body. We already know that the soils are depleted, but that's a shocking amount of minerals that we're losing. Now here's something very interesting. This study from Senapati in 2009, the authors observed the following: disruption of mucosal folds and disarray of microvilli structure in the intestinal wall, along with exaggerated secretion of mucin throughout the alimentary tract. These features are highly reminiscent of celiac disease. Now these researchers were studying glyphosate, and what they found is that glyphosate is almost identical in microvilli damage to what celiac disease is. So if you know anything about celiac disease, you know that the villi that we spoke about, that I taught you about early in the lecture, they become atrophied. That reduces their ability to absorb nutrients and bring it into the system. Which one of the main things with celiac disease is very consistent diarrhea, malabsorption. They're very low in vitamins and minerals because they can't absorb, you know, all those vitamins and minerals. If you remember that picture that I showed you of the digestive tract where all the vitamins and the minerals are absorbed, people with celiac disease have a very, very, very strong inability to absorb those nutrients. So these researchers found that with excessive exposure to glyphosate, people have the same symptomology and physical signs and atrophy of the microvilli and the villi in the GI tract as people with a genetic disease in celiac. So it's a very, very fascinating combo. Now I do want to say that Dr. Alessandro Fasano's work has proven clinically, scientifically, that alpha-gliatin, the protein structure in wheat, does destroy the villi, and it does affect zonulin and tight junction function. But what further science like Dr. Senev's work has shown is that alpha-gliatin is a rather big structure that needs to be broken down, and in a future video I'll explain the whole thing about alpha-gliatin and tissue transglutaminase and that kind of stuff. But what I'm trying to tell you is that alpha-gliatin is a destructive structure on that whole process of the tight junctions. But glyphosate is a smaller molecule that can get there and can be actually even more insidious. So I'm not trying to take away from Dr. Fasano's work and gluten sensitivity. There is scientific basis to that. But I think the stronger correlation to the villi atrophy and the tight junction dysregulation is more associated to the glyphosate currently that we're all exposed to. This will explain the incredible increase in celiac disease in the last couple of years and non-celiac gluten sensitivity, because we didn't genetically all of a sudden become more susceptible to celiac disease. It just appears that you know, the celiac disease is expanding, and it's not because of better diagnostic criteria. We're still diagnosing the disease with the same concepts, but you could actually find people with a glyphosate microvilli destruction that is very similar to a person with celiac disease that is a genetic condition of sensitivity to alpha-gliadin. And furthermore, Dr. Fasano's work is also trying to tell us that maybe it's not just the protein structures in wheat. It could also be rice, it could also be oats, it could also be barley, etc., etc. But as I've said, or will say in this lecture, you will see that some of these other grains are sprayed with glyphosate as a early harvest trigger. You know, a desiccant is what we call it. So just an interesting piece of information for you. This could also tie in very strongly to some of the symptomology that we see with people with gastrointestinal disorders, which is really what this whole thing is about, right? Intestinal permeability. Okay, so we're going to go a little bit more in here, and we're going to look a little bit at Dr. Seneff's work, and this is going to be kind of association to what we've discussed before, but more specific to your personal intestinal permeability, which I once again believe that everybody has a level of it because of the exposure to these particular chemicals. So Dr. Seneff has shown systematically that all the features of IBS, IBD, Crohn's disease, celiac disease can be explained by glyphosate's known properties, and they are the disruption of the shikimate pathway, which I've explained to you, the altering the balance between the pathogens and the beneficial biota in the gut, which we'll go a little bit deeper on in a couple of minutes, the chelation of transition metals as well as sulfur and selenium, as I explained to you, with the bushels of corn and the vitamins and minerals that are being depleted. And we already discussed the cytochrome P450 enzymes, which are very involved with detoxification pathways. So Dr. Seneff's team argues that the key system-wide pathology in celiac disease is impaired sulfate supply to the tissue, and that is also a key component of glyphosate's toxicity to humans. So we're not going to go into the sulfate thing. Just remember that sulfation has something to do with detoxification, and that is inhibited, and sulfur and sulfate is very involved with many diseases, and maybe we'll do a lecture in the future specifically on that. For the points that you need to remember is just remember that glyphosate affects the shikimate pathway, which is the pathway of how the bacteria in your gut live and produce their own amino acids and help you with those amino acids. Glyphosate unfortunately destroys more the commensal than the pathogenic species that we will discuss in a couple of minutes, meaning that the reality is that more of the good bacteria get harmed than the bad bacteria. The chelation means the desiccant factor, the pulling of the minerals out, and then the cytochrome P450, which is detoxification. So if you understand those four concepts here, you're good to go. Just understand that in autistic children, autistic spectrum children, we find consistent selenium deficiencies, sulfur deficiencies, ammonia buildup because of lack of detoxification, and consistent Clostridium species overgrowth, which is a pathogenic species. So if you look at these 3 to 4 points, I can completely tie autism to the equation here. Now we're going to keep going further and further, and once again, folks, I know it's a lecture in biochemistry and toxicology, but you need to understand where I'm coming from so you can see the seriousness of what I'm trying to address here, and not go hop off and eat 5 Dunkin' Donuts and think it's a cheat day. There's no such thing when it comes to this toxicity. And even though I'm going to give you ability to be able to handle this stuff better, you need to get away from these particular things as much as you can, right? So glyphosate's high solubility in water, as we explained before, it's water soluble, and the ability to be absorbed by plants is another reason for its herbicidal efficacy. and its rapid penetration into the ecosystem. I already told you it's a very, very effective thing. Hundreds of millions of pounds of glyphosate are approached to U.S. farms per year, and there are more than 1.2 billion pounds that are used worldwide each year. The volume of usage of this herbicide has led to the reports of significant levels of glyphosate in the water, the air, the rainfall, and even human breast milk. Now you might say, man, you've been saying all that, where's that factual? How's that scientifically proven? There are your references. Go read them, go look at them. You will find glyphosate in breast milk. You will find glyphosate in baby formula. You will find glyphosate in the mom's blood and urine. You will find this stuff everywhere, so it's impossible to get away from, and it's a massively saturated product in our food supply. We can't get away from it immediately, and this is the whole purpose, obviously, of this particular lecture. Now we're getting into some of the true nitty-gritty of glyphosate. So glyphosate is patented as an antimicrobial. Remember I told you that it was applied for a patent in 2001, and it only got approved in 2010 as an antibiotic. And it has been shown to disrupt the gut bacteria in animals, preferentially killing beneficial forms of bacteria and causing overgrowth of pathogens. And this is now scientifically being shown, and this is what we find in autistic children. And what's the thing with autistic children? They normally only like to eat 2 or 3 or 4 foods, right? So, and normally those foods are very glyphosate-ridden foods. They want to have fish sticks, or they want to have fries, or they want to have, corn or whatever it is. They only eat like 5 or 6 different foods. And those 5 or 6 different foods are mostly loaded with glyphosate, which making the condition worse. And as we said that, unfortunately the good bacteria is destroyed because of the shikimate pathway, but for some reason, some of these Clostridium species and E. coli species seem to survive, and that's why we have this massive overgrowth of E. coli and Salmonella, from some of these Clostridium species. So let's look at this. Glyphosate disrupts the balance of the gut bacteria in poultry and increasing the ratio of pathogenic bacteria and other commensal microbes. Salmonella and Clostridium are highly resistant to glyphosate, whereas Enterococcus, Bifidobacterium, and Lactobacilli are especially susceptible. So you can clearly see that Lactobacilli and Bifidobacterium, which is the good bacteria that we're always trying to take in a supplement form, is what's being destroyed by the shikimate pathway. So you're going to say to me, no problem. I'm just going to take some more Bifidobacteria and Lactobacilli species and I'm good to go. No, you're not, because Bifidobacteria and Lactobacilli species don't pass through your digestive tract. They cannot be taken in. There is less than a 2% absorption on some of those bacteria, which is when we're talking about the reseeding, is going to be even more factual to you. So yes, am I saying that taking the Bifidobacteria and the Lactobacilli is pointless at this particular time? Pretty much, because that stuff doesn't survive the GI tract. So let's look at the facts and figures. You have glyphosate killing the good bacteria that you can't really replenish through supplementation. And you have glyphosate that is basically killing the good and making the bad thrive. Now, if we look at the analysis of autism kids, and I'm going to keep coming back to this because autism is basically the worst GI disorder you can have. Because most kids with autism, or not all kids with autism, have GI disruption, constipation, diarrhea, food sensitivities, detoxification problems. Everything that I've been speaking to you about so far is highly associated to the use of glyphosate. Currently in the world, there's a condition that is jumping up and biting us consistently, and why I put this in here is because this is clearly part of permeability in the digestive tract running from the nares to the rectum. And that's the esophageal epidermal lining that is being heavily injured for some reason in the patients, and especially following the glyphosate ingestion. And there's something called eosinophilic esophagitis that is really consistently becoming a consistent issue, and also the associations with esophageal cancers, acid reflux, or GERD, or any of these other associations, maybe directly or indirectly. Just wanted to kind of mention that. And then in the 2013 study of Zahawi, the most common symptoms in acute response from glyphosate poisoning was ulcerations, nausea, and vomiting, which is something that we are kind of seeing consistently. And most of the time when people get these kinds of ulcerations and things, they're just putting on more medicine, and that's not necessarily doing anything, because you're not really removing the active ingredient that's causing most of the problem. Before we get to the antidote of glyphosate at this particular point, because yes, Dr. Bush's work has provided us with something as phenomenal as a potential antidote or a mediator at this particular point from the use of this dangerous chemical. So let's look at some of the studies. In 2012, in the Food Chemical Toxicology Report, long-term toxicity of Roundup herbicide and Roundup tolerant genetically modified maize by the Cerulini study, the health effects about Roundup tolerant genetic modified maize were studied for 2 years in rats, and in females, all treated group died between 2 to 3 times more than the controls. Females developed large mammary tumors almost always, and the pituitary was the second most disabled organ. And if you know anything about pathophysiology or biochemistry or biology, you'll know that the pituitary is a phenomenally important little organ as it communicates with most of the hormonal function in the body, and the anterior pituitary, for instance, is the thing that signals the thyroid. So this could explain a lot that's happening in the human population. I understand that this is an animal study, but it could certainly play a massive role in our understanding of the human disease as it is today. I'm going to keep going further with these studies because I think it's important for us to look at this. More information. Liver congestion, that clearly has to do with the cytochrome P450 enzymes that's affected. Nephron damage in the kidneys was 1.3 to 2.3 times greater. Males presented 4 times more large palpable tumors than controls. These results can be explained by the following: endocrine disrupting effects of Roundup and their metabolic consequences, specifically as it relates to the pituitary communication to the rest of those organ systems, is very, very interesting to understand. So for the layman, understand that this is liver, kidney, cancer, and thyroid problems that we're really talking about here, which is very common in clinical practice today. Continuing with some of the fantastic work of Dr. Seneff and Dr. Samsel, these CYP-T enzymes that we have spoken about before, they could also be directly and indirectly involved with the massive vitamin D deficiencies that we're seeing in the population. We already discussed the tryptophan and tyrosine association. We already discussed the sulfate. One thing we didn't discuss was the massive depletion of zinc. But then again, it makes sense when we're talking about a chelating agent. It's pulling all the minerals out. And zinc is highly involved with tons of functions, but specifically the immune function. And then the induction of excess synthesis of ammonia in the gut, which is another thing that we see with autistic children. So if I just look at this page, autistic children, vitamin D deficiency, consistent. Tryptophan, tyrosine, and emotional mental disruption, which are truly related to those aromatic amino acids, consistent. Sulfate, which is the sulfation and detoxification, consistent problem. Ammonia toxicity, consistent problem. Remember, ammonia is a breakdown product of certain amino acids, and if we have too many of them, or proteins as you would call it, they become neurotoxic. And isn't autism a reasonably neurotoxic condition? And then zinc deficiency, a lot of these kids are very immune suppressed and very sensitive. So once again, it backs up everything. And if I keep talking about autism and you say, but how's that related to me? Because I'm not autistic. GI. Autism is the worst GI condition in the world, right? It's the worst form of intestinal permeability that you can find in an individual would be autism. So if you want to classify anything as the worst form of intestinal permeability or leaky gut, it will be autism. So that's the bottom and the worst of the worst. Now you are somewhere on that spectrum from an intestinal permeability standpoint, and I'm hoping that I'm making enough of a case here for you to truly believe it. And one of the reasons I'm doing this is because I'm trying to get away from just having people believe what I'm saying. You know, I mean, here's the science. Here's how my brain works. I'm putting you inside my brain. I'm putting you inside my head for you to learn why I do what I do and why I approach what I approach. And if you're one of my patients, you will clearly know that I'm pretty pertinent on certain things, and I want to show you why. I don't want you just to believe what I'm telling you and then go out and do a little cheat and think it's okay. I want you to understand why it's important to be so compliant, especially if you want to improve your condition. And for all my patients that are always compliant and great, and I have a couple of them, I salute you and thank you, because that's also why you're having the results that you're having. But this is the next step. This is the next level. So in conclusion of the gloom and the doom of what this product does, it is very associated in studies in the Food and Chemical Toxicology reports in 2013 to human breast cancer cell growth. And you know breast cancer is an epidemic. Glyphosate-based herbicides produce teratogenic effects. Now that means teratogenic or teratogenic, however you want to pronounce it, with me being a little bit of a foreigner. It basically means making a monster. You know, there are children born without proper brain formation. Some of them are born without limb formation. And you could see that from Agent Orange back in Vietnam, you know, and that's pretty much the same deal that we're dealing with here. So it's nasty stuff. And then chronically ill humans have higher glyphosate levels than healthy humans. So if we measure your level of glyphosate in my office by virtue of a urine test, we can determine what level you are. Now this is from the environmental toxicology papers, and these are all peer-reviewed journals and all very recent studies. So you know, I think we're onto something, and I think we have the measures and the ability to reduce glyphosate in your body that will reduce your tight junction dysregulation and your permeability, and we can certainly hopefully improve your condition. So just to get back to some of the final principles here, the glyphosate compound is 10 times more potent than gluten on the zonulin toxin pathway to destroy the tight junction. I mentioned that a little bit earlier with Dr. Fasano's work. This is coming straight out of the mouth of Dr. Zack Bush, that he found that in his experimental research that glyphosate is 10 times more potent than gluten, which would explain why Dr. Seneff's finding of this excessive association between celiac disease and glyphosate is so similar, and this is just backed up again by Dr. Bush. So he also states that when you lose bacterial diversity, and you see this from the generations where it's happening faster and faster with our increase in autism and behavioral issues, and have toxins present at your tight junctions, the earlier you will start manifesting the aging processes and chronic disease manifestation. So we're seeing this more and more and more, and earlier and earlier and earlier in young people. We're seeing now alcoholic liver disease in kids at the age of 15. We're seeing type 2 diabetes evolve at much earlier ages because of that sulfate and things that Dr. Seneff is talking about. So just about all these conditions could be very, very strongly correlated to this. And if anybody says, well, not one thing can cause everything, no, but this is a pretty strong argument for something that is in our food supply. And if you look at the increase of diseases and conditions over the last couple of years, this only makes a ton of sense. Why we are seeing this. I'm in clinical practice for 20 years, and I've seen an increase in food allergies pretty much year by year, proportionately in clinical practice. I can't remember peanut allergies as severe as they are now, and it might not even be the peanut. You know, there's some mycotoxins on it. There's some fungal toxins on peanuts that could be even more causative to the problem than the actual peanut. But that stuff's not even really investigated yet. You know, everybody's blaming the peanut. No, the peanut contains a fungus, and that fungus gets into the gut, and that gut doesn't have proper tight junction. Then you might have a disproportionate overgrowth of that fungi in that person that could be more disruptive than the actual protein structure or the lectin structure inside of a peanut, which is a legume, by the way. It's not a nut, right? Final piece of biochem. While the exact mechanisms for tight junction dysregulation from glyphosate is unknown, it is plausible that it is similar to how gluten disrupts tight junctions through the upregulation of zonulin, and the zonulin occludens toxin, ZO2 pathway, or the ZOT pathway. Glyphosate systematic actions are likely unique due to its small molar size and the ability to pass through the plasma membrane. Now, I did mention this earlier, so in a nutshell, in a layman's term, glyphosate has a similar effect to tight junctions than gluten. But glyphosate's a lot smaller, more insidious, and gets through a lot quicker. So it's certainly something that we need to start digging into. Now, as far as zonulin is concerned, folks, so basically zonulin is, this is the gate. Zonulin is the gatekeeper. So zonulin tells the gate, open up, close, open up, close, open up, close. So clearly the more it keeps open, the more zonulin activation is there. Some of the zonulin gets overexposed. We can actually measure zonulin levels in a person's plasma or blood. Not something I think we need to do at this particular point, because I think everybody with severe GI permeability is going to have, you know, a reasonable amount of that present. I would be much more interested to just test your glyphosate levels in your urine and see how that improves, because that's going to improve everything else if we look at the consistent pieces of information that I'm bringing to you right now. So what are we doing about this glyphosate? How are we going to get this glyphosate to get out of our systems, to dissolve it, to make it better? And this is all credit to Dr. Zack Bush. So Dr. Zack Bush stumbled upon a carbon molecule that looked a lot like the chemotherapy compounds that he was working at when he was working at the University of Virginia. Now, and that's going to sound crazy. I mean, why do we need to know about a chemotherapy? Because when Dr. Bush was working in chemotherapy, he was clearly trying to design drugs that could destroy cancer cells, right? And what he's basically saying is that in nature, he found something that was very similar in the ability to destroy bad cells or bad things in some of the research that he did in this particular product and the soils that he's using to manufacture this. So these molecules in soil was the bacteria in the soil that were creating these carbon-based molecules, not the soil itself. They had this oxygen communication system on the end of them. These are referred to as redox molecules in biochemistry. These redox molecules are unique in that they do rapid cell-to-cell signaling and seems to be the backbone of how the immune system will respond to injury. And perhaps more importantly, how the immune system will regulate its response to the injury without mounting into a chronic inflammatory response. So part of the problem with intestinal permeability and gut dysbiosis and microbial imbalances and chronic diseases is the consistent inflammatory state, because we're not getting rid of the active antigen or the active ingredient that's causing this consistent attack on the human system. Glyphosate being that antigen. Basically, in a nutshell, what Dr. Bush is trying to tell us here is that in nature, in soil, these soil microbes produce this little molecule, this carbon molecule, and this carbon molecule creates a network. So in Dr. Bush's explanation, he says, well, think about a cell tower and a cell network. You know, it's not the cell phone that's doing the job, which is the cell. It's the communication that comes from the cell tower to the cell phone. So what the product is doing, where the glyphosate is disconnecting the cell communication, is basically clipping the ability for the receiving of that cellular signal. This particular resoiling concept that we're talking about will reignite the cell signal throughout the whole system in the human body. And as I explained to you in the path that Dr. Bush did in his work in the introduction section, you will clearly understand that this man is not making this stuff up without looking at it in a lab with a triple board certification and owning a lab that's doing all the research on this particular stuff. So just for your geeks, and I have a couple of my patients that are kind of in that I want to know more, and I want to know more about the science of this stuff. This is basically what redox potential is, and this is what Dr. Zack Bush is talking about. And you can basically see it's basically the loss of electrons or the gaining of electrons. That's basically what redox potential is. And if you're looking at this, as you'll have reducing a compound A, which basically A is an oxidized that is losing electrons, and then B is reduced by gaining electrons. So it's just basically the loss and the gaining of electrons. And if you know anything about electrons and disease, you would probably know something about what is that called, if I can get it off the top of my head quickly, SED rate, sedimentation rate. There's something called Rolax stacking, which is to do with red blood cells, and that has everything to do with the charge and the electrons being given and lost on a red blood cell. So if they negatively charged, they're working different than when they're positively charged, and that has everything to do with how these electrons go back and forth. But from the principles of what we're trying to do, is this is just basically a very basic explanation of what the redox potential is all about. So what is in this resoiling product that we're talking about? What does make it work? What is the active ingredient in it? So there's been a lot of research on humic and fulvic acid as far as this is concerned, but Dr. Bush went a little bit deeper into this. So soil derivatives like humic acid, fulvic acid, and silagit end up a tremendous amount of oxidative capacity, meaning it can actually induce an inflammatory injury and apoptosis in the kidney tubule cells, which are like the canary in the coal mine. So many people are using humic acid and fulvic acid to pull toxins out of the body, and in the work that Dr. Bush has done, he has found that could actually be quite dangerous, even though he still believes that the answer is in the soil, and obviously the microorganisms that obviously hand off, these redox potential that he was mentioning in the previous slide. So Bush uses this particular product that he obviously designed, and what he really uses is the lignite extract, the LES, or the lignite extract supplement is what he has come up with, which contains about 20% of the concentration, and then it's purified water. So this lignite itself is comprised of 150 milligrams of what they call terahydrite, which is a trademark of what they extracting, out of the soil. And the lignite extract is an alkaline pH over 7.0, and therefore cannot be considered humic or fulvic acid because it's more acidic. So they've basically taken the concepts of these soils, modified it to a level where it is more environmentally friendly in your GI tract, kind of the way that nature would provide it to us. This supplement also contains purified water as well as a proprietary blend of the following ingredients, comprising less than 1,500 parts per million inorganic compounds like chloride, sodium, lithium, calcium, phosphorus, sulfide, bromide, potassium, iron, zinc, copper, gold, magnesium, and then the amino acids alanine, glycine, histidine, isoleucine, methionine, threonine, and valine. These are all very important essential amino acids, or most of them are, and obviously all those little minerals that he's talking about there are in trace amounts, the way that you would find them, in nature, the way that you used to take food out of the ground and kind of just wipe it off and eat that soil. It's kind of conceptually the same thing that we're trying to get to. I'm not trying to pretend that I know what Dr. Bush knows. I'm sure that if you go and look at some of his videos, he can give you a more in-depth scientific explanation than I just did. But basically, we are working with a modified form of soil here that is very utilizable in the human body in this particular lignite extract. So to go further on this particular discussion, with a decrement in nutritional value of our food, clinicians worldwide have begun to turn to fossilized foil of this lignite that we spoke about, extracts for mineral supplementation for the human nutrition, as the nutrient density in the soils decrease due to modern agriculture, and we just know that for a fact, right? Not to mention that the glyphosate's sucking all the good quality minerals out anyway, and where they find this is clearly in areas where there hasn't been exposure to glyphosate. So these acids that we had spoken about, the fulvic, the shellagite, the humic acid, are naturally oxidized lignite extracts that have been utilized as a mineral supplement in Asia for hundreds of years. Due to their oxidative nature and the frequent contamination, their use in clinical settings has been limited. Significant toxicity introduced from both the mining and the manufacturing of these mineral supplements have been in numerous commercial studies. These are the studies that show you that just using straight up fulvic acid, humic acid could be toxic unless we're doing it in the form that Dr. Bush is talking about. Do you really need to understand anything about these last two slides as far as the oxidation potential of fulvic acid and humic acid? No, just understand that a person that has a massive science background has looked into soil research and he's studied soil. He's not just a guy that's going to believe everything that everybody's telling him. And from the knowledge that he had in chemotherapy and lab and medical experience from research, he evolved, designed this particular soil derivative into a way that is non-toxic and deliverable to human use. And they've done this with cell culture studies, and you will see very shortly how this actually does improve the tight junction function by the use of it. Now on this particular slide you can actually see that there's a control group, and these are obviously some of the cells in the cell walls and the tight junction that we're talking about. Then you have the glyphosate group. You can clearly see how the glyphosate is disrupting that and allowing these gaps to form where all this problem is happening. Now this lignite product that Dr. Bush is talking about, he calls Restore, and you can see how that's Restore. And this is a person taking in glyphosate and using Restore at the same time. You can see that there's still a little bit of a gap here and there, but it's certainly a hell of a lot better than that. So it's pretty impressive what this can do when you're looking at it from a cellular and tight junction perspective. Now here's even more proof to you of what can happen when you introduce glyphosate in cell culture. This is within 2 minutes of introducing glyphosate on that epithelial cell layer, and within 10 minutes how many gaps are formed and how much of this tight junction regulation is disrupted. And this is within 12 or 15 minutes, I believe, if you look at the third picture. So it's pretty shocking to see what an effect glyphosate in its own way has. Now you already saw in the previous picture what glyphosate can do with this lignite product that Dr. Bush has evolved. So am I actually saying that you can be exposed to a little bit of glyphosate and actually have the improvement? Absolutely. That's what we're trying to say. I don't think that we can't, but it will be fantastic if we consistently measure the pre and post, correct? Now here you can see the improvement once a person or that cell culture was exposed to the lignite extract as well as the glyphosate. You can see that that is certainly a heck of a lot better than what we saw. You can actually see the tight junction regulation, coming back to a little bit of normalcy, but you can almost see immediate improvement, as you go on from the 2 minute, 10 minute, I believe it's 12 or 15 minute period, over here. So this is pretty strong evidence that you can have immediate improvement by taking this lignite extract, and some anecdotal case studies have shown that. I have personally been using the product for a while. I have seen some changes in certain areas. I don't think maybe my body was as compromised from a intestinal permeability aspect, but the soil and reseeding process I am doing consistently myself and have done for a while. As you know me by now, I've never done a diet or created any protocol that I haven't done myself. And I don't think there's many medical doctors that can actually say that they've tried every drug that they prescribe. So, from my standpoint, I feel that we have something really phenomenal here. I'm certainly taking no credit for the design of this. But you know, ironically, as I do the next presentation of Dr. Christian's work, Dr. Christian and Dr. Bush haven't yet put this together in one protocol. That's kind of something I've done, and then obviously I add the nutritional component that they haven't done to do the refeeding, because if you're restructuring the soil and you're reseeding, then at some point you need to refeed, because if you go back to a bad diet and you're refeeding the wrong things, that's not really the objective here, right? The objective is long-term improvement of overall health. So we're almost reaching the conclusion of phase 1, and I hope you have picked up quite a bit of information from this. But this study demonstrates the capacity of lignite extract to block glyphosate-mediated injury in small intestinal and colon epithelial membranes, even at glyphosate levels 50 times higher than allowable in foods like corn and soy. So the pictures I just showed you and the slides I just showed you was actually this particular study. The direct effect of lignite extract on large and small bowel tissues evaluated in this study include rapid increase in tight junction expression, indicating a strengthening of the intestinal barrier function. The public health ramifications of these results may be significant, as intestinal permeability from tight junction dysregulation continues to be recognized as the foundational cause of chronic inflammation, as I've measured before. So we potentially have one part of the antidote to protect us while we're still being exposed to this. My strongest suggestion is that everybody consistently stays on the stuff. This is not something that we go off until the food supply is completely improved. As I've mentioned before, and I may be repeating a little bit, your gut starts in your sinuses. So when you breathe, the mucosa of your nasal passages are tied together with the same tight junctions and network that you are going to find in your esophagus and the small intestine. So when I'm talking about intestinal permeability, I'm talking about from the nose to the rectum, folks. It is the entire digestive system. These tight junctions, proteins get damaged when we have overwhelming effect of the immune system. A good 80% of the body's immune system lies behind these tight junctions. Now, this is an important one to remember, because we are going to talk about this in phase 2, which is the gastrointestinal associated lymphoid tissue, or the GALT. And this is where you will produce 80% of your antibodies that will protect your system. As you start to picture the gut lining, consistent communication with bacteria, we can start to understand how the immune system really starts to function. So when we have a breakdown of this, we are exposing our immune system, and we will be under consistent attack, which is then perceived as an autoimmune condition. But we basically have the gastrointestinal associated lymphoid tissue that's communicating through the tight junctions. It's just on the other side of the tight junctions. The bacteria and the nutrients are going in there. They leave it alone, but as soon as you send big things through there that are undigested and unprocessed and toxins, then you are going to absolutely have a cascade effect of immune response that's going to lead to food allergies, sinus problems, skin conditions, diarrhea, constipation, chronic diseases, and even more serious diseases like ALS, MS, cancer, renal failure, liver failure, and everything that goes with that. So am I actually telling you that what we're talking about here is absolutely the air in the tire? Absolutely the air in the tire. We've got to get the air in the tire, otherwise it's a meaningless tool. A tire with no air does nothing. Now, little air is better than no air. Too much air is also not a good thing. We just need to get the right amount, but the tire needs to start getting some air into the equation. Folks, now we are going into phase 2, which is the reseed. Now, we have spoken about the lignite extract from Dr. Bush. That is our soil. So we are going to resoil, and every one of us is going to have a slightly different progressive dose of the soil, depending on the severity of our intestinal permeability. Now we're going to start talking about the reseeding, because remember, glyphosate destroys the shikimate pathway, and then the shikimate pathway pretty much destroys all the good bacteria, as we've spoken about. It doesn't really hurt the bad bacteria. What are we going to do about the good bacteria that we need to resoil or reseed? We've got nice soil in there now. Now let's go plant the seeds in there to see what we can get out of this. And this is where Dr. Krishan's work is now going to be the topic of major discussion in the next phase of our presentation, which is probably going to be about the same duration as the previous one. And in order for us to completely get to the bottom of reseeding, which to me is the bacteria, right? We need to discuss the differences between prebiotics and probiotics and exactly what they mean. So a prebiotic is defined as a non-living, non-digestible special form of fiber or carbohydrates. The powder form of prebiotics can survive heat, cold, and acid, so they can get through the digestive tract unharmed. And prebiotics perform their role by nourishing the bacteria that live in the intestines. So what do we know here? It's a non-living organism. It can get through the stomach acid and harsh environments to go feed the bacteria. Okay? What is a probiotic? A probiotic is referred to as a live microorganism that when administered in an adequate amount will be a benefit to the host. Now, this is a very important definition to explain, because if you're taking probiotics that are not making it through the digestive tract, then it cannot really be seen as a probiotic. So lactobacilli species and bifidobacteria species, which is the majority of probiotics in the United States of America, are anaerobic bacteria. They can't live in an oxygenated environment. They are completely destroyed, as we'll look at the studies in a couple of minutes, by the harsh gastric environment, the duodenal cavity, the bile that's sequestered by the gallbladder, the stomach acid juices, all these kinds of things play a point. So that brings us to the point that it's more fragile, it's very vulnerable to heat, and it might be killed over time. So if we're looking at all these probiotics that are shipped in hot trucks, in the back of container trucks to get to the GNC store, you know, in the inside of those containers, and I know that for a fact because I used to pack some of those containers, it gets to be 140 degrees sometimes inside those containers. Now, I know you're going to say to me, yeah, but some probiotics I can get it shipped to me and they're frozen. Might be better, but you're not going to freeze your digestive system in the form of your hydrochloric acid, right? You're not going to be able to freeze your stomach acid to prevent that from breaking down those bacteria. So probiotics fight the harmful bacterial species in the gut. So the beneficial bacteria or the good bacteria is what we really want to put into the gut, because we already know that the pathogenic species seem to survive this glyphosate exposure. All right, folks, so the next slide is pretty interesting, as it basically explains to us a little bit about the diversity of bacteria in the gut. So if you know a little bit about math, let's just look at this one here to start with. We can see that in the stomach we have the factor of 10 to 1 of lactobacilli species, H. pylori species. There's actually some fungi in there as well, Candida. I think there's some streptococci in there. So there's various species that live in the stomach. So sometimes what's interesting is, for instance, H. pylori overgrowth has been shown to be eradicated or improved by the use of Manuka honey. And it's fascinating because if you look at the content of Manuka honey, so the H. pylori starts to overgrow, and then the Manuka honey contains large amounts of lactobacilli. So maybe it works because the lactobacilli species are increasing in the gut. That way it is suppressing the excess H. pylori species, and that's how the commensal system works. Just to give you an idea. Now, as you see here, as we go further on, you can see that we go to the 10 to the third factor, the 10 to the fourth factor. Now, this is the duodenum. And if you remember that picture that I showed you, this is where a ton of those foods are absorbed. It's like 12 inches long. Just about all the nutrients in the world are absorbed there. You know, like you have your potassium, you have sodium, you know, a bazillion, potassium, magnesium, iron, you name it. Everything is absorbed there. Then you go further down in the duodenum, and then right here in the distal ileum is where a lot of your vitamin B12 is absorbed. B12. B12 is absorbed in this particular area. But the point that I'm trying to make is that the progressive increase of the amount of species is astronomical. So the amount of species that we have here versus here is incredible. So here's what I want to explain to you, that if a person has small intestinal bowel overgrowth, right? Small intestinal bowel overgrowth. So let's go to CIB. I'm not very good at this, but I'm going to give it to you. SIBO, small intestinal bowel overgrowth. It basically means that bacteria from down here, because of pH changes and changes in the system that could be because of processed foods or proton pump inhibitors, stomach medications, antibiotics, artificial sweeteners, these bacteria in abundance go all the way up here. And then you start getting real big problems because you're eating certain things and you bloat and you feel like you're extremely overweight when you eat certain foods, and that is part of intestinal permeability as well, because as these microbes start moving into different directions, these pH changes, this tight junction thing is going to get affected. So basically SIBO, and there's also something called SIFO, which would be small intestinal fungal overgrowth, where you can actually have the fungi species moving around. But these are just a couple of the species that you can look at. So if we now look at section B, and let's draw that one in green, we can see that the mucous layer and the epithelial surface contains these species: lactobacilli, enterococci, and clostridium species. Now we do know that clostridium species are somewhat immune to glyphosate, and so are some of the the E. coli species, I believe. And then if we look at the intestinal lumen, we find all these species. So you can now see that just taking lactobacilli and bifidobacterium, they are, here's lactobacilli again, here's bifidobacterium again. But the big thing is that we have clostridium species here, which is a bad one, supposedly. We have some of those entero and streptococci, which is a bad one, which is the cause of strep throat. Why are we supposed to have all these things in our system? You know what I mean? Because there is no such thing as good or bad bacteria. There is just a balance. Now, what we're not seeing here is the fungi. What we're not seeing here are the parasites. What we're not seeing here, other than the bacteria, is the viruses. All these things work together on a consistent basis in the human body. So, here is a key component to what we are talking about. From the age of birth to 1 year of age, which is why vaginal birth through the vaginal canal, being exposed to lactobacilli, female's vagina has a very acidic pH, around about 5.3 or something to that effect. And lactobacilli is an acidic species, so the baby gets, very much plastered in those bacteria. Then the breastfeeding happens, and you can see that all biome increases in numbers and diversity almost up until the age of about 1. Right at that point, there's a massive cutoff, and then from here on out, the numbers are maintained, and obviously the composition is continuously evolving because of changes in diet and changes in nature. But it's almost like your bacteria in your body form a fingerprint, like at the age of 1, and it almost seems like they always want to try and go back, to what that was. So if you weren't breastfed, and if you weren't vaginally birthed, we do see consistent more elevation in allergies and that kind of stuff in patients. Now that doesn't mean that we can't treat a person like that, but that person might need to have additional work done other than just a normal resoiling and reseeding. In these kinds of patients, we might need to do very specific species of Akkermansia. We need to do very specific interventions, maybe of what am I thinking about here? Clostridium, colostrum, not Clostridium, sorry, colostrum, species need to be given to these people because they miss out on the colostrum in the initial phases. Also IgG modulators that we can, immunoglobulins that we can give to them, and nutrients. So what I'm trying to tell you is, if you haven't been breastfed and you have a GI issue and you have intestinal permeability, my approach to you might be a little bit different. It's still going to be the resoiling, reseeding, but the reseeding might have more tentacles in more specific and aggressive microbes that we know pass through the system well. So this is a good indication to you of where we are. So here's just a quick little follow-up of what I just spoke about. The baby, obviously, to the age of 1 is where most of the biome and diversity is formed. This is why it's so important not to sterilize your children, have them play in the mud, have them walk around, claw around, put stuff in their mouths. If put a bug in their mouth, big deal. If they pick their nose and put something in their mouth, it's not the end of the world. This is kind of how our systems just evolve, from a biome seed point, and that's the seeding, and we are actually talking about our form of seeding, which is a hypothetical, but certainly makes a ton of sense to me why we could make that work. It takes approximately 838 days to adult-like microbiota from the period of birth all the way out, and then from there on, it's the environment that you create. If that environment is hostile, then it's going to, if your diet's hostile, your environment's going to be hostile. If your diet's good, your environment's going to be commensal and balanced, and that's really what it's all about. So any diversion from this natural process leads to disease. So if I go into a natural birth with a healthy upbringing, I have a better chance of getting my biota back to normalcy. But as a general rule, you are what you eat and absorb, right? And it's almost like, Dr. Jeff Bland used to say, people used to say you are what you eat. That's not true anymore. You are what you absorb. That's kind of true. You are what you absorb that gets delivered inside the cell. That's important, right? Because I can have stuff being absorbed into the bloodstream, but it doesn't necessarily mean that it's getting into the delivery area of the cell where it needs to have the improvement. My theory is, if you have a compromised GI tract, what you're absorbing is toxic because your tight junctions are so open and you're getting all these toxins into the system that you don't want there. Now, I'm not going to spend a ton of time on this particular slide. It's just very interesting to read if you actually look at this. And this is coming from the Invisible Residents from the Human Microbiome Project. And you can just see all these different species that we find from the gut to the mouth and the teeth. Microbes found in the ears, the vagina, the nose, the tongue, the tooth, the cheeks, the gut, and the stool. And if we keep putting a ton of makeup on, and I'm not saying we shouldn't brush our teeth or wash ourselves, but you've got to get away from this heavy-duty antibacterial stuff, because if you start messing with the biome on your arm, they actually reckon that sunscreen is affecting the biome on the arm so much that your body cannot have the natural vitamin D absorption, which is causative of vitamin D deficiency. So, we need a little bit of direct sun exposure to this, and don't always believe that the sun is the cause of skin cancer, right? Melanoma is one of the worst forms of skin cancer, and very seldom is the actual melanoma found on areas that have been skin exposed to sun. So that's an interesting topic, but this is just fascinating how many bacteria they found in the microbiome project so far, and we're only scratching the surface. Now we are going to look at some slides of science and research, which I think is very applicable, because once again the education to me is very important here. So let's look at this. So we have used comparative microbiome profiling of a cohort of CRS chronic rhinosinusitis patients and healthy subject. We demonstrate that sinus microbiota of the CRS patients exhibit significantly reduced bacterial diversity. So we're seeing less diversity in people with rhinosinusitis, right? High diversity has been generally associated with a health and temporal stability. Conversely, a relative lack of diversity is apparent in the gut biome and diseases ranging from obesity to inflammatory bowel disease, type 1, type 2 diseases, and skin microbiome and atopic dermatitis and psoriasis. And this is a very recent study in 2016. And I don't know if you know much about professors, but that's what we do. You know, when we design a protocol or we design an intervention strategy, we look at the literature, right? We do evidence-based nutrition. And when I did my introduction, you know, I think I mentioned that I am holistic nutrition, clinical nutrition, human nutrition, and evidence-based nutrition. So if you have all those together, you're not missing many divisions of nutritional therapies, right, or intervention strategies. This study in 2005 was indicative of an evaluation of the probiotics effect in the human gut and microbial aspects, just to kind of determine where we're at. If I can get this slide to work, it doesn't seem to work for me. All right, so the purpose was to evaluate the probiotic effect of commercial products in the human gut, any effect on the gut flora. 35 strains from commercial products were studied, primarily Lactobacillus species and Bifidobacterium species. And they were to evaluate the survivability of the common probiotic through the gastrointestinal tract. That's what the GIT stands for. So this is getting to the probiotic thing, you know, why we're pumping ourselves full of all these probiotics. So step one, they measured the survival through the gastric juices in the stomach acid for 20 minutes as a pH of 1 to 3, which is normally what digestion would be. pH of 1, none survived with any viability, unable to recover. And generally, like I said, the pH of the human stomach is between 1 and 2.8. So at 1, none of them survived. At a pH of 2 to 3, 18 of the 35 showed a 50% survival through the GI tract. In step 2, the survivors through the stomach were tested for the survival in the upper and small intestines via bile acid tolerance. Remember, when you digest something, food goes into from your esophagus into your stomach. Stomach breaks it down. Then it goes into that little duodenum where all those nutrients are absorbed. And then there's a bile duct that comes in that helps emulsify fats. Remember, the fats that you eat aren't digested in the stomach. They're in the small intestine. And then the bile comes in there and it breaks it down. So now these bacteria are going to be exposed to the bile. So first they get exposed to the stomach acid, and then they get exposed to the bile, right? So the survivors through in the small intestines for the bile acid tolerance led to, of the 18 tested, only 6 showed viability in the presence of the bile acid salts and would have the chance to make it to the large intestines. In step 3, the 6 strains were then chosen for survival testing in the lower intestines, and of the 6 strains, 4 strains showed viable in the lower intestine conditions. Only 4 of the 35 strains ended up in the large intestines, and the survivors of that would have less than 50%, which now basically means that the bacteria that you took, remember, in the large colon, the factor was 10 to 12. That's big time, right? Big number, right? Millions, bazillions. Now you're taking a probiotic that's 50 million, right? That's not even close to what you have in the large colon anyway. And if you remember the definition of the probiotic, it has to be live and has to have a purpose to the human. If you're giving one less of 1/10,000th or 1/1,000,000th of a percentage of what already is in that biome, you're not effectively taking in a probiotic. But let's say effectively 4 out of these 35 strains made it at 50%. That basically proves to you that the probiotics that we take have very little improvement. Now later on I'm going to talk about fermented and non-fermented foods, and you will quickly find out that fermented foods I'm a big promoter of. Why? Because it has probiotic nature, but those probiotics might not survive. But we also don't know that for a fact because it's combined with fiber, it's combined with a prebiotic, it's combined with enzymes that we don't find in a probiotic supplement. So the food in its own way that's getting into the system through the fermentation process might be a little bit different. The science isn't totally clear on that yet than just taking a probiotic supplement. But even if it isn't, even if it doesn't survive, the fermentation process is extracting the nutrients so much better out of the fermented foods that when you're eating it, you're getting a direct hit of better nutrient density immediately, even if the probiotics really don't make it to the end. I doubt that. I think nature provides its own catalysts to protect it from the bile and from the stomach acid by virtue of carrying molecules and binding molecules that we might find in the future to be valid. So this is just another slide. If I can get this up here. Yeah, so the 4 products tested, the 1 leading retail brand supplement, 1 leading yogurt, and 1 leading Greek expert versus the Probiotic, which is what we are talking about for our reseeding. So now remember, we had the LE product from Dr. Bush, the Restore, and now we have the Probiotic that we are talking about that actually proves that it survives transition and transport through the GI tract. So we were looking at Ultimate Flora, Chobani, and Dannon yogurts, and the spore-based probiotic that we were talking about. And they used a simulated gastric solution again for 1.3 to 2 hours, and then the bile salts were added, same as the previous study. The data is based on the percentage of survival of the bacterial population. The test products, other than the Megaspore probiotic or the base spore probiotic, were sourced directly from the lab and from the store shelves. And the results were the following. Both yogurts had started counts. Regular yogurt had higher counts, but both yogurts saw over 99.99% of the probiotic bacteria die off in the stomach. So that whole thing about yogurt getting probiotics, questionable. The leading supplement brand had nearly 4-fold overage, but over 99% also died in the stomach. And the Probiotic showed 100% survival with no loss at all in the stomach. So here's a survival chart. The leading probiotic yogurt, no survival, 0.063 survival, 0.065 survival, 100% survival. And this is after exposure of 1.0 to 1.2 stomach acid solution, which is fascinating. Okay, so here we have aerobic bacteria seeding in an anaerobic environment. We know that lactobacilli is a anaerobe. It's a bacteria that lives in a non-oxygenated environment. This study looked at some of the more acidic bacteria like lactobacilli, so they have a little bit better chance to survive in the GI tract. And of the different strains of lactobacilli, the Lactobacilli rhamnosus and reuteri and Johnsoni, and the different forms of reuteri, the best adhesion was the Lactobacilli reuteri, and the second best was 24%, and went down from there. So even though they are more acidic in nature and they can probably handle that, they don't survive as well as we want. So a major issue in supplementation is sometimes the mislabeling of the products. Unfortunately, in the nutraceutical industry, there isn't a national governing body from the government to oversee the truthfulness or the protection of the general population by taking supplements, because it is not an FDA approved kind of an approach. So this unfortunately has led to a couple of companies not providing the best quality supplements. So let's say the supplement is supposed to have ascorbic acid in it. They can basically get away with having 4% ascorbic acid in a supplement and still calling it a vitamin C supplement. So this is why clinical practitioners like myself, doctors in clinical nutrition, chiropractors, and other medical professionals only buy products that are GMP certified. GMP means good manufacturing practices, and that means that the products that we are purchasing have been third-party certified. So the quality and the ingredients have been tested for contaminants, and therefore we can stand by the efficacy of these products. So obviously both of these products and all the products that we sell in our office is GMP certified. So this is basically just discoupling some of the mislabeling probiotic strains that we've seen in the literature. Some strains used may not have any studies or show any of their benefits. Several documented cases of mislabeled probiotics have been discovered. The products were incorrectly labeled with the wrong strains. The products contain markedly reduced numbers of the strains that were claimed to be in there. They found presence of strains that were not labeled and in some cases were pathogenic and even dangerous. So the quality control of probiotics is lacking. This study suggests that came out in 2015. And scientists at the University of California have found that the contents of many bifidobacterial species different from the ingredient list, and they basically did a study on 16 probiotic products and found that only one actually had the products in it that were stipulated on the label. So we just need to be aware of what we're buying and make sure that we're not getting our eyes covered with wool, right? So at the end of the day, for me, I really take my time in investigating the supplements that I sell to my patients from a quality control standpoint. So there is something that I would call the probiotic paradox. So what we can see here is that some of these organizations like the FAO and the World Health Organization Working Group defines that probiotics are live microorganisms which, when administered in adequate amounts, confer a health to the benefit and to the host. Therefore, by definition, viability is an essential requirement for probiotics. And the amount of bacteria that we have in our large colon, 10 to the 12th factor, it's very hard to actually take in that amount of probiotics, even in a capsule form, if you really analyze it. So effectively, they don't really fit the mold, or most of them don't fit the mold of actually what the definition of a probiotic really is. So the probiotic paradox, and this is the study that I'm referring to, live and dead cells are biologically response modifiers. So meaning that because some of these things aren't alive, we have already said that some of the bacterial species are affected by heat and temperature changes. And if you look at what we have in transport mechanisms of these probiotics, some of them at the back are tracks, they in very heated storerooms and facilities before they get there. Now I know that some of these things are shipped refrigerated, but have they been tested for their viability and their quality? That's always the question that we ask. So what you refer of as a probiotic is sometimes actually just a metabolic response modifier. And let's see what that really means. So what that means is that they are highly strain specific. For example, Lactobacillus rhamnosus, but not wild type of general Lactobacillus rhamnosus. They need to be specified. The effects are transient, which they're not really making permanent or semi-permanent changes to the dysbiosis or the etiology of the condition. They don't work across the board. The effects can dissipate. The studies focus on single strain at relatively low doses, which is not the definition of a probiotic. And single strain might have single effect. But there are some probiotics that have shown some benefit to some conditions. And, I'm sometimes wondering, what is the confounder reason for that? What is the association to that? It might be that person have low stomach acid, or they've had their gallbladder removed, or whatever. What brings that? So theoretically, a person with low stomach acid or compromised stomach acid and a person that doesn't have proper gallbladder function might actually get the benefit from some of this if we just look at what we explained a couple of seconds ago. But that's obviously not the standard rule in society. Be the proton pump inhibitors or stomach acid medication is. So if we look at the importance of the environmental bacteria, if we look at the biodiversity, which is extremely important to understand, we can see that the composition of the gut biota of healthy kids in Bangladesh, which are obviously exposed to a more moderate lifestyle, more natural foods, maybe not overfed, we are going to see that those people have a much more diverse biome. The same thing in these next two studies where they were looking at the fecal microflora in elderly persons in rural and urban areas, and they obviously found that the urban populations 2.6-fold less frequently than in rural hosts as far as the gut biome is concerned. So clearly our environment plays a big role in the diversity to our gut biota. So it's not just taking a bacillus spore or a probiotic or eating you know, a high probiotic dense foods. It also has, and prebiotics, it has to do with the diversity of it. How many different kinds of foods are you eating throughout the year? How often are you in the environment and actually touching the biome? Those biomes are affected with your exposure to the environment. That could maybe be the reason that we have less issues in summer, because people are outside more and they are exposing their gut biomes to a more diverse situation. The Hadza of Tanzania have been studied, and these people have unbelievably strong GI systems. This is pretty much the last hunter-gatherers on Earth and on the planet, and they live an ancient ancestral life, and it hasn't changed for about 1,000 years, and they have a massively diverse microbial community, vastly different compared to the westernized populations, and they do not have GI diseases. They do not have Crohn's disease, they don't have diverticulitis, colon cancer, reflux disorders, which is pretty interesting if we really analyze it. Now these people also eat a tremendous amount of fiber, and you can't just go and change your diet to theirs, because that will really put you into a flat spin, even if it is a very healthy diet, because your microbes have to be adaptable over time to this particular situation. So that's just interesting to look at. But we as a population need to become more diverse, and that's also the objective of the refeeding stage, is to get biodiversity in it. In the old days, like I said before, 600 foods were eaten by the ancestral folks. Same with these. 600 different kinds, you know, different tubers, different vegetables, different plants, different greens, different animal proteins, different nuts, different seeds, whereas we are very consistent in what we're eating. So you can't have diversity if you're eating the same thing over and over and over again. You're not giving your body a challenge. It's the same thing as working out with a 5-pound dumbbell and thinking that eventually you're going to build muscle by using the same dumbbell. You have to give the body more resistance. You have to give it more of a challenge. And as our pursuit continues here, we will see that the requirements for a true probiotic, to summarize again, they should naturally survive the harsh gastric environment. There should be a strain that is found in the microbiota. It has to have binding sites that belong to the gut, that have been there from a standpoint of evolution and for a very, very long period of time. We can't just invent something completely new. They must have evolutionary significance, as I just stated. They must be a facultative anaerobe, which basically means that they have to be able to live in a non-oxygen environment, because that's where they thrive in the GI tract. They must have a biphasic life cycle, which means that they should be alive inside of you and they should become dormant and spore forming once they leave your system. So these are amazing bacteria, spore bacteria, because they encapsulate themselves and protect themselves from harsh environments. So they don't give themselves any chance in your stomach. They encapsulate and enclose themselves. They get through the environment. When they get into an area where they're comfortable, they will come out of their closet, so to speak, and evolve into a commensal species in your body. They must have clinical demonstration of safety and efficacy as well. So the bacterial spores that we're talking about, and now we're getting into the nitty-gritty of what we are talking about, in particular these bacillus spores, or bacillus species, I call them bacillus spores, as they are the most widely studied and the most widely used probiotic outside the supplement market. Now, what is really going to irritate you is that what I'm going to share with you now is nothing new. This has been around since the 1950s, I think 1958, that some of these companies were producing these particular spores in a probiotic form for people with gastrointestinal issues, able to help them in the medical community. But of course, the greed and the manipulation and the corruption again led to pharmaceutical companies suppressing the data on this, because you cannot really totally patent these things, because they are species that have been around for millions of years, you know, they've just been pushed aside. So if you look at the bacillus spores, like I said, they were first introduced as a probiotic in 1958. The Enterogermina and the Bacti subtil were two products. They've been used extensively in the animal, in the agriculture, as Alcare, BioGrow, BioPlus, Neofirm, and Liquilife. Most widely used and well-studied strains in the humans from a biota standpoint are Bacillus subtilis, Bacillus licheniformis, Bacillus coagulans, Bacillus clausii, and Bacillus indicus HU36, which is actually a trademarked bacillus species that has some antioxidant ability, ironically, by megaspore biotics. So these species are in spore form. They can pass through the gastrointestinal tract, and these are the babies that we're going to be using to reseed our new soil. So what they do, these spores, they form robust endospores that can withstand harsh temperatures, desiccation. And isn't that interesting, because we spoke about the desiccant in the form of glyphosate, right? It is a desiccant. You know, low stomach pH, they can withstand gastric barriers, antibiotics, so antibiotics don't kill them. UV radiation, solvents, enzymes, and even high pressure. They are found all over our environment: the soil, the vegetation, the dust, the rocks, the aqua environment, our digestion of insects, marine life. So they've been a part of our world for over 50 million years. They found all over in ancient environments like the ice core studies. They colonize very effectively in the human gastrointestinal tract, and have been found to colonize very effectively in the gastrointestinal tract of different animals. They're also found as a part of the normal commensal flora in humans, and it has a long history of industry where efficacy is closely measured in the pharma agriculture, and they're extremely safe. So it's basically the first probiotic that we can say that is truly commensal organism, and it's evolutionary supported. So the amazing thing about these endospores is how they encapsulate themselves. So if you look at this, you'll see it has an outer membrane, it has an inner membrane, it has a germ cell wall and a cortex, and this thing is extremely tough. You know, it's almost like a seed that is eaten by an animal, and the seed goes right through the digestive tract and gets fertilized back into the soil. These endospores really don't do anything in the soil. They just lie there dormant until they get their next carrier. So they've really got this longevity thing down. You know, they know how to live a long time, and they know how to perform at their top level. So the functions of the spores in the gut obviously is colonization. So we want them to colonize the GI tract, and they have the absolute ability to regulate the species. So when you eat your food and you get them in and you only have pathogenic species, you will feed those pathogenic species to extreme. If you get the spores into your diet and you feed them the right nutrients, what's great about commensal bacteria and pathogenic bacteria and the symbiotic relationship between pathogenic bacteria, commensal bacteria, if you want to call them the good and the bad, the parasites, the viruses, they are working in harmonious balance with each other. So they are willing to share. Because they're sharing you, they're not selfish. They will only get selfish and aggressive if the other populations aren't around. So the bacillus species, the lactobacilli species, the bifidobacteria species, the viral bacterial species, other than what we've just mentioned here, the fungi, they can all live off the food supply that you provide, and they would be more than happy to share with each other in their own little communities. Numerous studies along in the long history have confirmed the survivability of these spores in the GI tract. The studies have shown that the spores are well adapted to germinate in small intestines, so they're really designed to live there, and they can proliferate there, and they can resporulate when they leave the lower GI. This ability to resporulate is clearly an evolutionary adaptation, as several factors of Bacillus spores require resporulization in the lower GI tract. And this is again where we tied into the GALT. Remember, we were speaking about the GALT, the gastro-associated lymphoid tissue, which is on the other side of that little membrane of the GI tract with that tight junction discussion. And these spores have the ability to communicate with this GI very effectively to be involved with that tight junction regulation. So this on its own has also shown improvement in tight junction regulation. As we said, it's a universal commensal probiotic. And studies now indicate that the environment is simply a vector to transfer the bacteria from host to host. So it's really just there lying dormant until it gets to another person. So further functions of these spores is these spores have the ability to shift the microbiota in favor to the growth of the good bacteria. Remember, I told you when you're taking glyphosate, you have the Clostridia species and the E. coli and the wrong kinds of species are growing aggressively while the other ones are dying out. These Bacillus spores have the ability to basically reactivate and repopulate these species, and you can see in the studies that they produce an antibiotic effect in their own way in our bodies. They are competitively exclusive of the pathogenic organisms. They compete for the space and the nutrients. As I said, if your bad bacteria or your pathogenic species are eating and these guys come along, they will compete. They'll push them out. They'll take some of the food away from them and they will eat it. So the increasing growth of the GIT commensal species such as Lactobacillus has been shown clinically to improve, and gut model studies have demonstrated that nearly 30% shift in microbiota population with continuous administration of Bacillus spores. Now read what that says, continuous administration. It means that you have to consistently take it, and it takes time for that to be reprogrammed in the way that it has been done. So this is actually demonstrating that this is the only probiotic that has ever demonstrated that it can regulate tight junction function and actually has the ability to fix dysbiosis. And I know you must be kind of tired of some of the scientific terminology, but stop it. Continue tomorrow, listen to it another day, but keep listening to this as we just explained that it helps the ability of developing the GALT. It does this with the cooperation of the Bacteroidetes fragilis species, so there is a connection between the communication of these Bacillus spores and other species. Bacillus spores increases the circulating T and B lymphocytes by becoming active in the small intestines and stimulating the Peyer's patches, which is the area that we actually use to activate some of these lymphocytes. And these lymphocytes are obviously our immune cells, right? So Bacillus spore shifts the body from a Th2 inflammatory state to a Th1 adaptive state via stimulation of toll-like receptors 2 and 4, CCR5 and interleukin 12, and tumor necrosis factor alpha. Now, this stuff sounds completely crazy to you. Here's what I want you to understand about Th1 and Th2. Right? So Th1 is the Rangers or the Marine Corps or the SEALs. They go in, they attack, they move out. The National Guard comes in with the collateral damage and stays there and helps the local population out for as long as they need to. Unfortunately, in this particular war, the Th1 guys went in, they went out. The Th2 guys have been there forever. They haven't been able to go home. They're overworked. They're overstressed. They haven't seen their families. They're not eating well. So you get into a Th2 dominant state, which is a chronic disease state. So Th1 acute, Th2 chronic. There should be a balance between Th1 and Th2. The Th1 should go in within 90 hours they should be out, and then the other guys need to go in there. But because of this consistent intestinal permeability and tight junction dysregulation that we have in our bodies, we are consistently in a Th2 dominant state. When you're in a Th2 dominant state, you are going to have consistent inflammation in your body that is going to be causing autoimmune-like symptomology, because you have these lipopolysaccharides going through, as we've explained. You have these bacterial species and undigested food particles that get into the system, and toxicants and chemicals that also play a negative role in our bodies, and that causes these allergic responses that we now know. So it is improving our adaptive and our innate immunity, which will actually help us, better control our allergies and immune function. Furthermore, they produce these bacteria, and these spores help produce a full array of vitamins and minerals for us to eat. They also produce something called short-chain fatty acids, and they have been shown to increase the short-chain fatty acids by nearly 40%. One thing that is consistent in autistic children, as we said, elevated ammonia, but low levels of short-chain fatty acids. In all the stool testings that I've done and tests that I've looked at, when I look at a person with severe IBD, inflammatory bowel disease or irritable bowel syndrome, I see people with very, very low short-chain fatty acids consistently. So that's a consistent thing, especially when we get to discuss the different levels of intestinal permeability. The people at level 2 and level 3 are generally the people that have short-chain fatty acid issues, and you'll understand the level 1 and level 2 and level 3 in a couple of minutes. It helps heal the colon, the short-chain fatty acid. It increases fat metabolism. It's an energy source for the colonocytes, so it actually produces food for these cells to heal and utilize. It supports the commensal organisms and lactobacilli and bifidobacteria, and it lowers cholesterol and triglycerides, as a matter of fact. And it reduces the systemic gut inflammation that's throughout the body, and it completely decreases intestinal permeability and helps leaky gut. So right now I have explained to you that we have two products that we're going to use as phase 1 and phase 2 in all the levels of intestinal permeability, and there are 3: level 1, level 2, and level 3, as you will be explained to soon, which is a creation of mine. And at all these levels of intestinal permeability, we are going to be utilizing phase 1 and phase 2 in this protocol, because both of them fix tight junction, and the spores are obviously helpful in repopulating the commensal bacteria. This new form of Bacillus species, DHU36, like I said, produces an antioxidant. Now we need to talk about LPS, or lipopolysaccharides, because I've mentioned it once or twice, and you really need to understand this. So we have elevated plasma levels of endotoxins associated with LPS, and as I have maybe mentioned in this particular lecture, that LPS is nothing more than the byproducts or the waste products of the bacteria that is in your body when they are digesting your food. So when we're eating food of any kind, but specifically high fat, trans fats, processed foods, we have a massive induction of lipopolysaccharides. And those lipopolysaccharides, when they open the tight junction because of dysregulation, because of glyphosate, these lipopolysaccharides are activating the immune system to overreact and attack them, and we feel toxic and brain fogged and fibromyalgia and chronic fatigue syndrome because of these lipopolysaccharides. Now, I will explain a little bit later that one specific species actually has a positive form of lipopolysaccharides, just as there is supposedly, good and bad cholesterol, and everybody looks at stomach acid as a bad thing when it's really a good thing. Anything that's too much is bad, and anything that's too little is bad. There is only equilibrium when it comes to the human body. So lipopolysaccharides are a problem when we have inconsistent tight junction, and as a matter of fact, excess lipopolysaccharides induces intestinal permeability. So this was the endotoxins, and what can they do? They can create shock, multiple organ dysfunction, depression, anxiety, sepsis, atherosclerosis, obesity, type 2 diabetes, Alzheimer's, autoimmunity, infertility, and hypogonadism. So you can see these are pretty much all the conditions that we consistently see in our clinical practices. And this is just kind of an explanation of how it looks. So if we look at some of the studies on this, metabolic endoxitemia initiates obesity and insulin resistance. Endotoxemia directly increases the proliferation and adipocyte precursors in the onset of metabolic diseases. Lipopolysaccharides cause an increase in intestinal tight junction permeability and in vivo by inducing enterocyte membrane expression. So there it is, right in front of us. We know that they cause tight junction permeability. Elevated endotoxin levels in non-alcoholic fatty liver disease, we find them as well. One of the major ways that you can have intestinal permeability, as I've mentioned, is alcohol. You know, when you're drinking a lot, you go out for a party and you drink and you feel all crappy the next day, headache, achy stomach, you know, runny stool. It's intestinal permeability. So elevated lipopolysaccharides in diseases, it drives the intestinal dysbiosis by chronic inflammation and macrophage recruitment. So the immune system gets overreactive. The Th2 dominance starts to happen. It depletes leptin resistance. So the ability of us to control our hunger pangs is limited. We don't know when it's shutting down, when we are actually full and not full, which explains some of the overeating. It's driving slow gastric emptying. And also on the previous topic is people always tell me, man, I can't stop eating these things. I am habitually addicted to these foods. That's correct, because you're intestinally permeable and some of these nutrients are escaping undigested and some of them are opiate triggers, and it's no different than being a heroin addict, right? It also affects ghrelin, which is another mood and appetite suppressant. It disrupts the blood-brain barrier and causes neuroinflammation. As I told you, if you have a leaky gut or an intestinal permeable GI tract, you will have an intestinal permeable blood-brain barrier. And that's just the way it works. So you can also see that there's associations here to depression. There's associations to cognitive decline, brain fog. There's associations to serotonin suppression, which is our craving chemical, and also the thing that converts to melatonin that helps us sleep. This is all in the literature, folks. This is all scientifically being shown. It causes an HPA axis with the overstimulation of adrenaline. And this leads to management issues of anxiety, poor management of anxiety, and adrenal fatigue. And it could actually also affect the receptors in the brain that are associated with chronic pain. And this is where the fibromyalgia comes in. So stress induces endoxemia and increases barrier permeability. This is permeability. This is just another validation of the association to the toxins and how they create these diseases through tight junction dysregulation. So summarizing, ground zero of most health disorders is intestinal permeability. The spore solution, here's a couple of studies that have shown the effects of Bacillus subtilis in the epithelial tight junctions of mice with inflammatory bowel disease. So they were able to reduce the permeability of these mice by virtue of these Bacillus species, specifically this one. And you can see here that they make mention here of Claudin, Occludin, the JAM-A and Z01, which are all these things that we have discussed already. You can see more Bacillus species studies here that show that there is better control of intestinal permeability and better control of the occlusion of the zonulin structures and the tight junctions. So this is all correlated to how, in layman's terms, how this is fixing the tight junction issue. So if we have the restore, if we have the Bacillus spores combined, we will have a massive, massive weapon. So in summary, the key findings of the present study is that the oral spore-based probiotic supplementation reduced symptoms indicative of leaky gut syndrome or intestinal permeability, and there was a 42% reduction in the endotoxins. So we're going to finish up with this little study that was extremely interesting. So they went to a university, and this was a 30-day study, and they took students and they told them for 30 days that they will pay for their meals. And clearly the best way to get to a student's brain is to tell them you're going to pay a meal from McDonald's. And they went there and bought their meals at McDonald's for 30 days. And what they were doing is they were looking at people only eating the McDonald's meals, and that there was one group, and one group was eating the McDonald's meals and taking these bacillus spores at the same time. And they were measuring markers of inflammation like, high triglyceridemia and other immune modulating associated inflammatory markers. And it was quite shocking that people on a bad diet with these particular products of bacillus spores were able to reduce the endotoxemia dramatically. So this proves to us that actually this particular product is sealing up tight junctions even on a bad diet. Now, do not think that I'm promoting a bad diet and just taking this stuff. But yes, this is the stuff that you should have at your disposal when you are doing your 5 to 15% cheat day once you've reached optimal gastrointestinal health. So it's going to help protect you so that you can have that piece of cake and that piece of chocolate and that bit of alcohol or whatever you want to go do, that gluten splurge that you want to go have, that you've been looking forward to for so long. So this is a very, very big potential. But you cannot just eat those foods, because you are going to feed the wrong species at some point, and it is going to cause, inflammation. So that's not the suggestion. The suggestion is to obviously feed the biodiversity, but also be able to have something in place that will protect you if you are not eating really well. So you can just look at the endotoxin measurements here, and you can see the improvement on all levels. The changes in serum triglycerides were positive. You will see that the spore treatment group had a 45% reduction in serum endotoxins, and the placebo treated group had a 28% increase. That is a radical difference. In conclusion, endotoxemia is the #1 cause of morbidity and mortality worldwide because of intestinal permeability. Metabolic endotoxemia leads to conditions like obesity, heart disease, autoimmunity, diabetes, hypogonadism, Alzheimer's, and every other condition that my patients are sitting in front of me with. Metabolic endotoxemia is a feature of a dysbiotic gut, imbalance of the gut bacteria. It affects the immune system as well as the endocrine system, which would lead to conditions like type 2 diabetes and Hashimoto's thyroiditis. The hallmarks are high serum lipopolysaccharides, especially after a meal. This elevates interleukin-1, interleukin-6, triglycerides, and postprandial insulin. This is also why in the dietary side you're going to see that I do focus on getting my patients on a glycemically controlled diet so we can reduce the insulin excess in the body. The bacillus endospores reduce postprandial endotoxemia and all these inflammation markers. By the way, folks, interleukin-1, interleukin-6 are all basically cytokines or inflammatory markers or natural inflammatory markers that your body is producing. And inflammation is healing. It's not a disease. But consistent inflammation in that Th2 dominant state is where the problems really start to happen. So you can also see that these bacillus spores are fantastic at lowering all these phases of inflammation. So the levels of severity in intestinal permeability intervention is going to be based on the following things. Level 1 is made of progressive reduction in people with moderate intestinal permeability. So these are the patients that are basically coming in with, starting points, not quality of life affecting intestinal permeability, maybe a little bit of constipation, maybe a little bit of diarrhea, maybe a little bit of bloatedness, but it's not all the time, but it's enough to be irritating to them. These are normally people that are coming from, reasonably processed diets. They really haven't been on extensive protocols, for food elimination. They eat maybe generally okay, but they're still exposed to most of the inflammatory foods. And with these patients, we're basically going to work with them on low glycemic, low dieting, cholesterol reducing dieting. We work with all those hormones dietarily to improve their condition, and then a progressive elimination diet. The level 2 patient is probably the most common patient. This is the person that comes in with experience, maybe with an official diagnosis of irritable bowel syndrome, or maybe inflammatory bowel disease, and they have already partaken in some sort of a dietary intervention where they are either on a small intestinal bowel overgrowth diagnosis with a FODMAPs diet. They might be on a specific carbohydrate diet. They might have a fungal overgrowth and on an anti-candida diet. They might be on an autoimmune paleo diet, a paleo diet, or any of these diets that are reasonably restrictive and staying away from either one component of food so that they don't get aggravated, like a gluten-free, casein-free diet for a very long time without permanent improvement in the condition. So these patients are generally very well educated in their condition. They've definitely made dietary changes, and they're trying to stay on those diets. The problem with those diets is that some of those foods that are being eliminated are really top level quality foods that contain a tremendous amount of good quality nutrients that we should really not stay away from for the rest of our lives. Like, for instance, the polyol diet, or the polyol category in the FODMAPs diet, which is what the P stands for, contains avocados, for instance. And then the sulfur foods maybe contain an avocado. And those two together, into those two different elimination diets could basically equate to a person having a severe issue with that particular food. But not eating that food long term is also going to create nutrient and mineral and vitamin deficiencies, because just an avocado by itself is a omega-9 fatty acid. It contains amino acids, it contains fiber, it contains phytochemicals, phytonutrients, and different vitamins and minerals that are essential to optimal health. And then the final patient, which is probably less than 7%, maybe even 5% of the patient base with intestinal permeability, are the patients that are so compromised that they physically almost drink water and they feel bloated. Their intestinal permeability is to the point where they're only eating 1 or 2 foods, and that's all they can handle. And that is going to be a mono-dieting approach, and very, very slow in progression, to get to the level where we can improve these people's health. So basically, level 1 would be the standard person on a standard diet coming in with some irritation. Level 2 is an official diagnosed IBS patient, chronic fatigue syndrome patient, fibromyalgia patient, irritable bowel patient, diverticulitis, etc., etc. That's already doing some sort of an intervention. And then level 3 is the severely intestinal permeable patients. At level 2 and level 3, there will be potentially some additional supplementation. We normally do Saccharomyces boulardii at level 2. At level 3, we might even do more advanced and more specific spores to help this person, get over this. But I can tell you at level 3, the people are very, very slow progression, and it's a very, very permeable GI tract. So let's look at some of the GI inflammation reducing diets that are out there just briefly, that people have been on and that you might be on for a little bit while we are working on healing your GI tract. But the optimal objective eventually is to have people actually be able to follow any dietary protocols that they really want to follow. And not saying that you should eat junk food, because that's obviously going to feed the wrong bacteria in the gut biome. But certainly 80–85% of the time, if you're really good, then you should be able to handle a little bit of a pizza or a piece of cheese or something that normally used to irritate you. And that's the main objective of this protocol, is to get you back on track, to be able to eating that, a little bit every now and then without the major issue. Because the reason that you're having those major issues is because of the permeability, as we explained earlier in the lecture. So some of these dietary approaches is something called a FODMAPs diet, which is really cutting out fructose and oligosaccharides, disaccharides, monosaccharides, and polyols. the specific carbohydrate diet, the Mediterranean diet, the autoimmune paleo diet, the Whole30 diet have been suggested as beneficial for healing inflammation in the gut. It's not healing the inflammation, folks. It's just taking the irritants out. Nothing there is healing the inflammation. Because if it was truly healing the inflammation, then you should be able to reintroduce more foods without them having, severe consequences. Now, I know that people can reintroduce some of those foods after a while that they've stayed away from because maybe of antigen reduction. But at the end of the day, if they eat a lot of that food again, that it will become an aggravator again. And there's certain foods that just will not be able to handle unless they do a complete permeable sealing and healing the way we have suggested in phase 1 and phase 2. And there's controversy is rampant between the various approaches. During periods of remission, the research and medical communities fail to agree on the dietary recommendations with any sort of detail. Additionally, the consumption of high or low fiber seems to be an area of debate because we know with the severely compromised level 3 intestinal permeable patients, you can't give them fiber. Even sometimes at level 2, if you give them a little bit too much fiber, they'll actually get the opposite effect of what you want. So it has to be very, very progressive in nature. Let's look at the specific carbohydrate diet. This diet basically is the avoidance of disaccharides and polysaccharides over a minimum period of 12 weeks, and this lays the foundation for the specific carbohydrate diet. This diet involves the elimination of all grains, all soy, processed meats, potatoes, yams, dairy, however allows minimal consumption of honey and unrestricted consumption of fruits and vegetables. So it's actually a very effective diet when you're dealing with somebody with small intestinal bowel overgrowth or some of the bacteria that have migrated that kind of live off these things or these nutrients. Positive outcomes were confirmed for children involved with a specific carbohydrate diet. In certain conditions, and I have referenced some of them below. So the specific carbohydrate theory claims complex carbohydrates overstimulate bacterial and yeast colonies, which leads to intestinal carbohydrate malabsorption. And that is true, but once again, the objective would be, we might keep you initially in this diet if you're feeling really good on this diet, but the objective is to seal and heal and reseed and resoil. And then obviously eventually reintroduce these things over time that you're not eating. The FODMAPs diet, which is probably the diet with the most amount of research of any diets on the market at the current time. This particular diet is quite similar to the specific carbohydrate diet. It has also been exclaimed as a beneficial diet for people with IBD. It's stating 50% of the patients experience decreased GI symptoms. I will admit that I have used this diet a lot in clinical practice with great success. But if you look once again at the foods that you're eliminating on a consistent long-term level, you got to question if the human body was designed to stay without those foods and without that diversification, because with a lack of diversification in the nutrient intake over the long term, you're actually going to exacerbate the condition because we want more foods. The Paleolithic and the ancestral era, people were eating about 600 foods per year, different kinds. We're eating between 15 and 25 as the average population. So we don't have a lot of nutrients that are diversified in our food intake, and most of them are chemically laden with the pesticides of glyphosate, and they're also processed. These people didn't eat processed food, so it made their microbiome more diverse. The more diverse a microbiome is, the less chance you have of intestinal permeability and autoimmune health. Just remember that as we go along and through this. The semi-vegetarian diet, this is another diet where people with IBD have shown some improvement. This special or semi-vegetarian diet was followed in a trial in hospital patients with celiac disease and Crohn's disease, and they found improvement with these conditions or with these people on this diet. From a symptom standpoint, absolutely, and I have no problem at level 2 and at level 3 even to use these diets while we heal and seal over a period of time. I do not want you to feel uncomfortable with the diet that you're doing. So if you're gluten-free, casein-free, dairy-free, FODMAPs, specific carbohydrate, Whole30, It's all the same deal. It's all really just the elimination of aggravating foods, depending on what those aggravating foods are to the specific individual. Here's a couple of handouts that you can just see what's a quick food quick food guide for anti-inflammatory foods on the left side and pro-inflammatory foods on the right side. So clearly in the initial phases, we will be working with these to try and alleviate some of the symptoms while we are doing the sealing and the healing of your GI tract. Here's a perfect example of the autoimmune protocol. I use this protocol very often. It's a reasonably diverse protocol, which is what I like about it a little bit more than some of the other ones, because I can get you up to nutrient status and some diversification to the point where I know that we can be okay. We see huge amounts of success with this diet in very short amounts of times from a standpoint of weight loss, inflammation reduction, you name it. I mean, we see great results with this particular protocol. These are the foods to avoid on the protocol, and you can see it's mostly some of the legumes, the grains, some of the seeds, alcohol, nuts. Now, eventually what I do is I reintroduce the nuts and the eggs as long as they, organic. I don't find that everybody has a problem with them, but most people have a problem with dairy. Most people have a problem with alcohol. Most people have a problem with non-steroidal anti-inflammatory drugs. Not all people have problems with the nightshades. Not everybody has a problem with the beans. But then again, what we spoke about earlier is that these beans and these nuts and these things are sprayed with glyphosate. So that might be the underlying problem that we need to deal with. Here's something that I do with a lot of my patients, especially with my level 3 patients, is intermittent fasting. Intermittent fasting has actually shown to increase the Akkermansia species in the bacterial biome, and that is one of the most diverse species or the most active species in healthy gut. As a matter of fact, they do produce a form of a reasonable healthy form of lipopolysaccharide. Not all lipopolysaccharides are dangerous and problematic. Anything in excess is a problem, but basically you can see that you eat between noon and 8 p.m. and the rest of the time you don't eat. Clearly between noon and 8 p.m. you are eating these anti-inflammatory foods or one of these specific diets that will decide which one is best for you. But the intermittent fasting, apart from regrowing some of the species and re-kicking the species in, and reducing lipopolysaccharide load, because every time that you eat you have high lipopolysaccharide status, and with tight junctions being open, those endotoxins go inside your body and cause a lot of problems. It's really exciting information to look at, to know that we can have success with this. It's also something that seems to release something called beta hydroxybutyrate, which is a ketone body that sometimes is very involved with healing in the literature, but we'll go deeper into that in the future. Also something that you can keep in mind, just as a general rule, there are things called dirty dozens and clean 15s. So if you are not able to always buy organic foods, the clean 15 could be bought not organic, and they'd be fine because they have less pesticides in, or their skin design prevents them from being oversaturated. The dirty dozen is the ones that we want to prefer to buy organic. But if you can't, you can't. It's still better to eat a non-organic veggie in the dirty dozen than not eating the veggie at all, unless you have severely compromised GI tract. What I always stimulate with my patients with the diversity, as I spoke about earlier, we want tremendous diversity in the diet because the diversity is what enhances the gut microbiome, and it enhances the diversity of the biome, which reduces the intestinal permeability overall. Now, each one of these diets will be discussed with you in specific, and you can see the different colors, and we have them all laid out for you, and we'll tick off which ones you should and shouldn't eat. But we are going to keep the diversification up, and we want to bring those up in the future. Just as an example of what I was speaking about earlier, a lot of people stay away from sulfur foods because they create a lot of problems with them. And just to look at the foods that are made, are in the sulfur family. If you look at nuts, bok choy, garlic, asparagus, cauliflower, onions, avocados, Brussels sprouts, broccoli, turnip greens, sweet potatoes, tomatoes, mustard green, and kale, you are getting rid of some of the most potent anti-cancer foods. You are getting rid of these cruciferous vegetables that show a great amount of reduction in breast cancer. or preventative for breast cancer because they produce a byproduct called indole carbonyl 3, which has been shown to reduce your positive and negative estrogens, or your good and bad estrogen balance becomes more normalized, which is, by the way, something we can test in urine, that ratio. The turnip greens, the nuts, the watermelon, none of these foods should be left out. Garlic, asparagus contains like 18 of the 20 amino acids. So kind of radical to stay away from all these sulfur foods. And if you have to stay away from these to feel better, there's clearly an indication that you're really not healing. You should be able to eat all these foods without consequences if you don't have tight junction dysregulation and intestinal permeability. These are foods that contain salicylic acid, and this is another thing that people tend to stay away from sometimes because of irritations. And once again, just look at the foods that you're giving up in this particular category, which could be helpful to your health. The macrobiotic diet is clearly something that I am fond of. I am very into the fermented vegetables. I'm into the vegetables and the whole macrobiotic plan, because I think it's a very diverse diet and a very good diet for enhancing the flora and refeeding the flora. But once again, we do this progressively. We will maybe start with a person on a standard kind of a diet, going to a low glycemic diet, going into a insulin controlling, cholesterol controlling diet, going into a elimination diet, going into an autoimmune paleo diet, going into a macrobiotic diet, so that we have all the diversification over time for that person to heal the GI tract. The people that are already on the specific diets, we might just go and progressively upgrade them into the fermented foods, maybe a little bit of beans, and get the diversification up so we can stimulate the back gut biome. But it is going to be a process, and it's going to take some time, and that's where the individualized part of this particular program becomes vital for our success. Fermented foods is something that I am big on. I do believe that they make a huge difference. Just remember, as I spoke earlier, I think that taking a probiotic and having the probiotics from these foods is a little different, because there's little different catalysts here. These foods contain fiber, they contain enzymes, and in food science we are not 100% sure yet exactly how all those molecules work together and how that food's carried on. So it might be a very good chance that some fiber and some enzyme is binding something that is able to get through the gastric a little bit easier than just a straightforward supplement. But even if it doesn't pass the gastric acidity, the nutrient density on these particular foods being extracted from the fermentation process brings you a power punch of a nutrient immediately, because it's almost like these foods are pre-digested for you, that are very helpful. So we will be introducing some of those foods in the future. Here are just foods that are high in prebiotics, because clearly if we want to feed the bacteria the food that they need, and we've discussed a little bit of that in Dr. Krishan's discussion area, or the phase 2 discussion with the reseeding, we need to eat these foods to feed the bacteria. And you can already see that some of these were kind of contraindicative with some diets and other diets, and this is clearly where we're going to help you. But these are the major foods that are high in prebiotics that we will have to introduce at some particular point in your diet, and we will be able to, because you should be able to have better gut balance. So finally, folks, here's our contact information. It's vital that you reach out to Angela. Even if you email me at ocoach@Natural Health Care Center, it goes to Angela. She's basically the gateway to this. There's our telephone number. And if you have any questions, please email them to us. We are clearly looking forward to working with you and continuing our relationship with you. But I do believe that through trial and error, and through the system and the program that I've put in place here, that I will be able and should be able to make you feel a heck of a lot better, and potentially get you to the point where you can enjoy a slice of pizza, where you can enjoy a cheesecake, where you can enjoy a drink. Clearly that might be only 15%, let's go 15 to 5% of your life, but you should have the opportunity without severe consequences of feeling completely ill when you're doing that. But you know, it was a privilege to spend the time with you. I'm happy that you made it all the way to the end of this presentation. I think it's well worth you listening to all of this. And you know, let's get cracking. Thank you very much.